Hey, good morning, everyone. It's a delight to have all of you here at this EU-India WaterTech Event 2024. I am Ravindra Gudi. I am professor at the Department of Chemical Engineering, also the Dean of Alumni and Corporate Relations at IIT Bombay, and the project lead for the Lotus project. I think um, it's from on behalf of IIT Bombay, I would like to certainly say that it's a delight to have all of you here, and to welcome all of you. We have a lovely campus, and over the next 2 days, I would like to invite you to please take a look at various departments, academic departments, centers of excellence. We have quite a few of them that carry out interdisciplinary research, but also enjoy the campus at large. We have a fairly nice green campus, and this is an excellent time of the year to be visiting IIT Bombay, the city of Mumbai. Yeah. Um, just a few words about the EU-India WaterTech event and the related projects. So initiated in 2019 between India and the European Union through the Research and Innovation Program Horizon 2020 Water Cooperation. This scheme has supported 7 projects, namely Lotus, Pani Water, Pavitra, Saraswati 2.0, India H2O, Pavitra Ganga, and Spring. I am delighted to extend a very warm welcome to all of the project partners who are here in each of these projects. Of course, I would also like to extend a very warm welcome to all of the esteemed members from the European Union Commission, as well as from the DST, DBT, and the review experts on various projects. Over the last 4 years, despite several challenges globally, and despite the various challenges that we went through in the innovation discovery and innovation process itself, there have been several exciting outcomes, and along the intended objectives of participation, co-creation, and looking at an initial proof of concept and impact, there have been several exciting work that has been carried out in each of these individual projects between the European Union entities as well as the entities from India. And this will be showcased during the day today and tomorrow. On the first day today, this is going to be a showcasing of the exciting water tech events, various technologies that have been developed, some of them potentially to the point of translation in each of these 7 projects. This will be a significant portion of today's proceedings. And tomorrow there will be several panel discussions and presentations on lab to market. Essentially, when we come up with these discoveries and innovations and try to enhance their technology readiness levels, TRLs, it's very important to understand the process, that the translation process that's fraught with several valleys of death. We just really want to overcome all of those and be able to take these exciting outcomes towards creating that societal impact in this very, very important challenging area of water. So certainly that the mechanisms to do that, the different perspectives from various stakeholders, including the researchers, the experts, esteemed members from the DST, DBT, and the European Union Commission, as well as the industry. It would be good to have all of those perspectives come together to be able to look at how do we translate these exciting research outcomes, typically at TRA levels of 3 or 4. How do we take them to TRA levels of 8 or 9 to create that societal impact? I think this is something that will be a major portion of the deliberations that is tomorrow, which is entitled Lab to Market. So in summary, I'm sure that we have an exciting 2-day event here today, showcasing the exciting outcomes of all the 7 projects, and tomorrow how do we take the next steps towards going to the market, creating that societal impact, industry impact, and the like. I would invite all of you to sit back, enjoy the proceedings, and share your perspectives. And as we go ahead, of course, certainly participate in the translation process as we go towards creating that societal impact. Just a few words, I think, regarding the ambience of this room. So we have two exits in this room, one on the top floor, so just leading to the steps to the first floor, the first level, and the one leading to the ground floor. Uh, the um, uh, the men's room and the women's room are just on the left, just behind the elevator. Could access that when needed. And in terms of the I think there is a small change in the program. Dr. Vashni had arranged a networking dinner, which we thought we would locate just behind this hall. There's a very nice ambience. But given that we had a larger number of registrations, this dinner networking event will now be held just outside where most of you are housed, the Padma Vihar and Van Vihar. Just across that, there is a Gulmohar lawn, and the networking dinner event will be held in the lawns over there, very close to where some of you live. The folks who have traveled from outside, I would begin with an apology that we did have some constraints on housing, although I did receive a lot of requests. I must apologize that I could not accommodate some of them, and you had to travel from outside. Excuse me, traveling from in the city of Mumbai is indeed another expedition by itself, but I hope it was a pleasant one to the extent possible. Uh, so the Gulmohar Lawns is just on the way, next to our Padma Vihar, Van Vihar guest house. There is a nice little pond there, and just by that pond, there is the Gulmohar Lawns where the networking dinner would be held. Like to invite all of you to please join there and have the networking amongst yourselves. So with those words, let me conclude by again extending a very warm welcome to all of you and wish you stimulating and very exciting deliberations, both by receiving your perspectives on the projects, but also by networking amongst yourselves. Thank you very much.
Thank you, Professor Goody, for your welcome words. Before proceeding, I would also like to just mention the auditorium rules for the event. Please switch off your mobiles, or you can keep them on silent mode. And also, this meeting is being recorded, so we would like to have consent from everyone. If anyone has any concerns over that, please let us know our computational team here. That was the second. And yeah, so now I would like to invite Mr. Perik Fillon, first counselor and head of research, EU delegation to India, for welcoming our participants for the event.
Good morning, colleagues. I'm very happy to be here today because I know several faces. This week, on Thursday, it will be my second year in India. So I've only been 2 years in India, but I work with many of you. So I would like to give just a few messages. First, I would like, especially in this water cluster, which is the largest that the EU has been building recently with ministries, a very promising area. We have to continue. So whatever we have done today is a first step only, and especially with all the European colleagues, scientists, Indian scientists, the ministries, DBT, DST, and now PSA, and many more, we have to continue. Water is a major area of research, including in Europe. We have water stress in Europe, as much as almost you have in India, water flood issues. So we need to put together solutions. And my colleagues, Bertrand, Giulio, Tanya, everybody here on our side, and I know on your side, you are all committed. So it's not a au revoir, as we say in French, it's a first step. My second message is this cluster has to go towards business, and we will try to see, because for administration, it's not always easy to reach out business, but absolutely we need to deploy them, hence the link with TTC and other pathways. So we really have to put our energy to continue on this group. And finally, I should have started, to say thank you for the welcome of IIT and Professor Goody especially, to all the colleagues. And there are in the room at least 2 colleagues who will retire soon, next month. So Dr. Washne and Tanya, so we will say something special afterwards. But it's really, you have been the engine of the cooperation between EU and India. I was just sitting in the car, but you were the engine. I would like to also say thank you, especially in my team, Vivek and Samrat, who is online, but all the other colleagues. And welcome also to all the scientists from Europe and India. I know a few of them. I would like to know more. I also want to, because it's not only deployment, it's awareness. I am discussing with a press department of our delegation in Delhi to try to see and bring together journalists in the domain of science to communicate on stories, especially the water story can be good for journalists. So I will pick up on some of the projects later on via the colleagues in India and in EU, how we can make stories and put it slowly in the various newspapers, both in India and in Europe, to show what has been done with taxpayers' money. So those were the messages. And my last message is, when I was speaking at breakfast with colleagues, I realized that the water cluster started or was initiated before COVID. We almost forget, but it was a hard time that everywhere we went through, and that cluster of scientists held despite the COVID situation. So I applaud to the work of the scientists and the laboratories behind to, despite COVID, continue and today come together. So thank you very much. And as I said, it's a collective effort. So I am humbly appreciating all your support. Thank you to all the colleagues. I give no name, but I am thinking about all of you. Thank you. Bye.
Thank you, Tariq, for your warm welcome. To go ahead, I would now like to invite Dr. S.K. Vaishnav, Advisor and Head International Cooperation DST, for giving a brief opening remark for the event.
Thank you, Dr. Abhilasha. And thank you, Dr. Ravi Gudi, for organizing this meeting over here. And warm welcome to all the participants for this meeting. I have always believed that whatever science we are doing should be for good of society. And when we are talking about water, it is touching each one of us in one way or the other. In fact, water is the elixir of life and we cannot live. But if we see what we have done to our water sources, there is a huge need not only to understand, but also to rectify. And with that spirit, we started this program long ago, and projects were supported jointly by department and also Department of Biotechnology along with European Union. And the idea was that it should not become only a research document. And whatever we do should be translatable and we could return it to the society in a much better form. And I'm so happy when I see the projects under this program have got varied dimension and are looking forward to deliver it to the society. Some demonstration plants have already been done. Some more are to be done with the participation of industries, NGOs, and other stakeholders. And we would love that society remembers it. That if somebody talks about India-EU cooperation, they should see that what they have done, what they have given to the scientific society, apart from what they have given to the scientific society. So our research should touch our hearts of our people, and whatever we are doing should be taken to the next level. I'm excited. Today we are going to review progress made under each one of them. And my request to all members of our review committees would be that not only they should look for what scientifically they have done, what are the good things and what are the corrections required, but they should also see how these projects could benefit society at large. And my request to all participating scientists would be that whenever you are taking your research, keep the human face in mind. And if you can bring smiles on human faces, your research is worth. Good wishes to all of you. Thank you.
Dr. Vaishnav, for inspiring us with the true spirit of the research that we take, that we all of us take. Next, I would like to invite Dr. Dhananjay Tiwari, scientist, advisor, Global Innovation Directorate, Department of Biotechnology, India.
Very good morning to all of you. We all recognize the technological interventions to address water issues. Actually, we resonate with the global concern how to address different issues related to the water. United Nations long back realized this importance and started science, technology, innovation as a tool to address sustainable development goals. And one of the goals is clean water, access to water, where extensively we have been using science, technology to address various issues. In different forum, in G20 also, we discussed about this issue and about the collaborative approach, building relationships across the nations, sharing our knowledge, technologies to address that. So at this outset, I would like to congratulate all of you that you have already been involved in this issue and working together to address very, very crucial issues as Dr. Vaste's lifeline of every human being and the planet. A range of technologies were used like reusing, recycling, desalination, advanced filtration technology, smart technology for monitoring pollutants in water. But I must tell you, in this space, technology space, biotechnology and biotechnology innovations have assumed very important and a very critical role to play. For example, biosensors, biofilters, bioremediations. And one of the aspects which can revolutionize the technology is the technology platform that is building up at the interface of synthetic biology and artificial intelligence. By way of that, you can engineer any microbes, you can change any genome, you can produce set of enzymes which can degrade any pollutants in the water theoretically, and also lots of success examples are there. And not only that, if we have something like that, microbes or enzyme system, we can scale up through biomanufacturing processes. So I'm very glad that Department of Biotechnology already supported three programs in this whole EU collaboration, Pavitra Ganga, India H2O, and Spring. And I would hear more about this detail of the program when we reflect on our achievements and progresses. Previously, Dr. Vasne and my EU colleagues also touched upon that translational aspects of the work. Whenever we have discoveries, we, of course, the convergence of effort is to translate them. And I must mention that Department of Biotechnology has one arm, BIREC, which is Biotechnology Industry Research Assistant Council, And the role of this agency is only to translate and support discoveries to tech to beyond TRL7 and commercial stage. And any translatable or any result arising out of this work has translational potential. Would be very happy to connect all of you with our agencies. I don't know tomorrow they are attending, but myself, Abhishek, all are there to connect all of you with that, so that we can also take next level for application development of the results coming out of this project. I would like to thank my EU colleagues, DST colleagues, to give me this opportunity. I just taken over, and it's more a learning for me, and I look forward to hearing all of you. We are committed to unlock every drop and make the world more sustainable and resilient and provide water security. Wish you all a grand success of this event. Thank you very much.
Dr. Tiwari, for your remarks with relating water to biotechnology. Next, I would like to invite Dr. Bertrand Ballet, Policy Officer, European Commission, to give a brief opening remarks for the event.
So, thank you very much. First of all, I think there is one person that was a lot involved in this project and is not in this room, is Dr. Panagiotis Balabanis. He couldn't come. He will speak a bit later, so we will have the time to thank him. But I think I can speak also on his behalf here. First of all, as Pierre said, I want to thank the IIT and especially Professor Goody for the organization of this event and to receive us in this institution. I think the call showed the benefits of collaboration between EU and India. On this specific topic that was reminded very important for the population, for all population in India and in Europe. We are all living thanks to water, and we need to have good quality water. We need to have good quality ecosystem also, water ecosystem, so we can live on this planet and protect this planet. We have developed technologies and approaches in both sides, and this call was the possibility to join forces on this topic. And I think the job that have been done is very important and is paving the way for future collaboration also. As it was reminded, an important aspect is also the transfer of the technology to the market. We will see that a bit more tomorrow, but a lot of technologies have been adapted from one context to another, which is very important. So we can transfer this knowledge, share this knowledge, learn from on the European side and Indian side from both sides with their different experience. I want also to thank Indian government to have made this co-funding possible with the European Commission. I think it's important to remind that we have different approach, but we can manage to deal with it, and because there is a final objective that is extremely important for both sides. I think I'm waiting for discussing all this all together to have this experience and build on this, and we hope that we can prolong also this experience in the future. So I wish you all a great event and lots of discussion to prepare the future. Thank you very much.
Dr. Bertrand. Next, I would like to invite Dr. Gilio Patan Rao, Research Program Manager, European Commission, to give opening remarks.
Morning to everyone, and first of all, let me thank our host here, Professor Goody, and more in general, DPT and ESC for the very successful cooperation that we started like 5 years ago for us as an agency. And let me extend these thanks and greetings also on behalf of people from the agency, my head of department, Paul Webb, my head of unit, Arnoldo Smilukas, my head of sector, Evdokia Kileos, and my colleague Christelle Millet and Veronique Voulet-Bonguet, that are all like involved in the management and monitoring of your project. Some of these people you met in the past physically or virtually. Unfortunately, they could not be here today, but really wanted to say hello and thank you all for this very, very, very nice journey. In terms of the what we are expecting from today, I think much has been already said, and there is the point that came like on the societal impact. Also, these projects, don't forget, you are the part of the Horizon 2020 societal challenge pillar. So as it was said before, it is very important for us as well to see now that we are at the end of the story, that also through technological development, you will ensure that the impact that will improve like more in general environmental condition in the specific like water management in both India and also Europe through the technologies that you have been developing to the project. So and we are really curious to hear today the final achievements of all of your projects. To be fair, like for you will be, 4 of your project will last a little bit longer, but I mean, we are really, really eager to know all your developments. And yes, we wish you all a nice day. I'm very curious to learn. And as Bertrand said also, let's see like if this gives like can open avenues for further cooperation and reinforced cooperation. Okay, so have a nice day and good luck.
Thank you, Dr. Gilio. With this, we have ended up with the opening remarks, and now I would like to invite Professor Ravi Goody for taking the proceedings ahead on the floor.
Yeah. We would like to go to the next aspect of session 1. But before we do that, it's somewhat bitter but mostly sweet kind of a little event that I would invite all of you to kindly join. It's mostly sweet because we are honoring one of our very distinguished scientists who has made a significant impact academically to the research and innovation ecosystem in India, but also in a way that builds international partnerships. Ladies and gentlemen, kindly put your hand together to welcome Dr. Varshni. Please join us on the stage, Dr. Varshni. I would just like to very quickly read about Dr. Varshni. Dr. Varshni is the head of the International Scientific Cooperation. So Dr. Varshni is currently the head of the International Scientific Cooperation in the Ministry, Department of Science and Technology, Government of India. He joined DST in 1990 and has been facilitating very deeply international scientific cooperation from the Department of Science and Technology with its bilateral, multilateral, and regional scientific partners. He is also presently the Indian co-chair governing body of the Binational Indo-German Science and Technology Center and the Binational US-India Science and Technology Endowment Fund both promoting joint industrial R&D. He's also on the board of directors of a private limited company, Geeta, Global Innovation and Technology Alliance, and is a member of the governing council of the International Advanced Research Center of Powder Metallurgy. He is the Indian focal point for BRICS Working Group on Science and Technology and OECD Committee on Science, Technology and Policy. He's also contributed quite extensively to the academia. He's been a member of the academic council of Dr. Hari Singh Sagar University at Sagar. He's also a member of the research councils of JSS Academy of Higher Education, Mysore, and Manipal University, Jaipur. Earlier, he was also the governing board member of the US IEF during 2018 to 2022, and the member board of studies of the Department of Geology at the Aligarh Muslim University during 2018 to 2020. He has extensively worked as a counselor, science and technology with the Embassy of India in Moscow to facilitate bilateral scientific cooperation between India and Russia. He's been actively contributing to the promotion of international scientific cooperation as well as scientific industrial cooperation. He's been conferred the Doctor of Science honoris causa by MIT University, Rajasthan. By way of training, he's Master of Geology in 1984 from Aligarh Muslim University with University Medal, obtaining the first position in the university. He qualified for the UGC NET in 1985 for the Junior Research Fellowship and Lectureship. He pursued research at the University of Delhi on Himalayan river systems, sedimentation, diagenetic, and tectonic modifications. He's also been awarded the Dr. D.N. Wadia Research Fellowship in 1986 for his research on Himalayan geology. He's written several articles on science policies focusing on international scientific cooperation. He's also involved in science popularization, which he writes regularly in newspapers, magazines, and journals. So ladies and gentlemen, I'm sure you'll all agree that we're looking at recognizing a very, very distinguished personality that's made a significant contribution to developing science, research, innovation, and towards impact. May I now invite Professor Prasad Paturi, Dr. Praveen Somsundaram, Tania Frederick, and Perik Filon Ashida, if I can, yeah, Perik, yeah, if I can invite all of you kindly to join me on the stage, please, while we felicitate Dr. S.K. Varshni. The customary Indian tradition of felicitating a distinguished personality is by offering a shawl and a coconut, which we call as Shrifal. I would request the esteemed dignitaries to kindly felicitate Dr. S.K. Varshni on his superannuation. Dr. Vashni, would you like to say something? Yeah. Like to invite Dr. Vashni to kindly say a few words.
And thank you very much, Dr. Gudi, Dr. Prasad, Tanya, Praveen, and Parik, with all of whom I have been associated for quite long. And of course, I haven't met each one of you so frequently, but now I'm going out of government service in a few days from now. I wish all of you very best, and I'll continue to work the way I do, of course, not as a part of the government, but to serve the science and to serve the community. And thank you very much for all the honor given to me. Thank you.
Thank you very much, Dr. Vashni, for all your distinguished contributions. I'm sure you'll never retire. You'll continue. You never tire in the first place, so there's no question of retiring. Wish you continued association with all of these international projects. I guess we'll go ahead with session one. Could I invite the session one is going to be a presentation of projects. Could I invite Professor Rajendra Prasad and Dr. Bernard Valley on the stage, please, to conduct session one? Thank you.
All of you. Good morning to all of you. I think it's a wonderful time and wonderful journey. All the 7 projects have really made through, consisting of more than, I think, 80 scientists who have been working, along with their young budding population of both Europe and India, who have been doing a wonderful job. That too on a topic which is of great relevance to the society and the humanity as a whole. I think in this context, it is time that the challenges, as every one of us know, that the challenges are different from place to place, nation to nation, and situation to situation, including within the nations. So in that context, I think all our friends have really done a great job of working out solutions from various dimensions and for various challenges. And it is time that we really try to have a look at what technology developments have been done. And here, once again, the most important factor that we should remember is it's a collaborative effort. And obviously, collaborative effect is going to be always better than a unified effect. So from that point of view, I think the achievements are really good and they are internationally comparable. And the only thing that we may have to also look into from this perception is its cost effectiveness, both from conditions that are prevailing, climatic conditions, and so on and so forth, plus the socioeconomic aspects that need to be considered. So from this aspect, I think we really foresee various aspects that have been developed in all these 7 projects and make sure that how best we can really translate them in the utility. That's the most important thing, either through an industry or by government mechanisms. I think that's what we should really look into. So apart from giving a solution to the challenges that you have really addressed, but it's also, I think, a responsibility to see that you design an approach which can be adopted in different parts of the world. That is something which I feel that it has to be brought out while you are making these presentations. Tomorrow would be a slightly different way where we really translate this into industry and business and so on and so forth. But for today, as far as the science is concerned, I think the scientific achievements that we have made, their simplicity, both from the technology point of view as well as from its replication point of view, and its impact on the society and the needs of the human beings. We request on behalf of both India and EU that please focus on that and then try to take the best possible time and then make sure that we get something out of it. I now request my colleague Bernard to say a few words on this occasion.
Yes, so thank you very much, Professor Prasad. I will not go extensively. I think the impacts that have the research project need to be adapted to the regional condition, and this is one of the important aspects that was at the center of these calls. I think we can jump on the results directly, and I will ask. So the first project is the Project Lotus. And I will ask Svetlana Klesova, Bérangère Lebenthal, and Professor Soubia to come on the stage to present the results. Thank you.
The Lotus presentation, please. Just want to be sure that it works before. Yeah. Okay, good morning, dear colleagues. We're very welcome to, we're very happy to welcome you here from the Lotus team. So we will have the presentation of the Lotus journey by our 3 colleagues. So Bérangère Lebenthal is our lead developer and lead scientist, Lotus sensor. And Professor Santil from ITG India is our lead Indian leader and technical lead partner. Myself, I'm the project coordinator. So I'll firstly start with a few words about the Lotus project, and then Bérangère will present you the sensor development, and then Santil will dig into further additional technologies, technological development in Lotus. And then I will conclude with the summary of the Lotus journey. Yes. So just a few words about the Lotus project. 5 years ago, we started and we wrote the objective in our proposal co-creation of innovative low-cost technology for India water challenges. Okay, and the main you notice the word technologies, the plural. Okay, the main outcome of Lotus is a novel multi-parameter water sensor. Actually, multi-parameter is a keyword here. You will see this on the next slide, why this is one of the keywords. Another keyword, and actually this what we changed it somehow in the project. It's no more the low cost, it's affordable. It's high quality, affordable technologies for Indian water challenges. So it was started with the novel started with a sensor chip, and then there was a complete sensor. So there is, I think until we have here a sensor, right? And then the idea was to connect the sensor through the Lotus box to different IT systems. So remember I mentioned that multi-parameter is a keyword. Why? Because if we look at the case studies, which we covered in Lotus, not necessarily at the same level. So we saw that in some case studies, the focus was on conductivities, on sodium. Oh yeah, okay, I have to, okay, that's okay, yeah, that's okay. So on different parameters, okay, you can see the slides, and we will despise the slides, I don't need to present here. So you see parameters for tanker water management system that was different than for irrigation or for drinking water, and so on and so forth. So actually we discussed all these parameters, and we work in 5 case studies across India. Okay, and again, I don't have time to present all of them, but our main case studies, we focused on the on Jalgaon, Bangalore tankers, and Guwahati water distribution system, and in Jalgaon it's irrigation water. Okay, so we discussed with more than 80 people, end users and their end users. Okay, so what is needed by them? So why it is needed by them and how we can approach them. So it starts with the promising technology, of course, but then there was a whole co-creation process. And fortunately, we had it just before COVID. I think just 2 months before COVID. So we were lucky here. And until we present further development in Lotus, okay, I'll not stop on here. We have limited time. We want to have time for questions. But a number of additional technological development was done at different tier levels, starting and ending, all this was so developed, advanced, and this is really work in progress, okay? So again, Santil will present the detail. And just the last thing for this introduction, in Lotus, we have a big consortium, like I guess all projects, okay, 21 partners from Europe and from India. I think the interesting feature here is we have very strong industrial representation in Lotus. So we have from one side scientists from Europe and India, and from the other side, we have SMEs, multinationals. So we have industry from both sides. And this is very important. Especially from India's side is also very important because they can guide us on the user's needs and so on. And this guides scientific research. And we have also non-for-profit organizations. So you see, it's diverse consortium. And when I will conclude with the Lotus journey, you will see why it was important. And with this, I leave to Berenger.
So good morning, everybody. I will take over for the technical presentation, not too technical, hopefully. So as Svetlana says, our job is to make a multi-parameter water quality sensor. And it has to be multi-parameter to target the different use cases that are presented to us in India. So to do that, we elected to use a principle based on carbon nanotube technology. And this is a concept called electronic tongue, which means to simulate with electronic system what our human tongue is actually doing, which is recognizing taste, quantifying taste based on our taste buds. This being said, we use very simple devices. In practice, you take a resistance that is sensitive to the parameter in the environment, a resistance which changes when the chemical environment is changing. And to do that, you need coating materials that are chemically sensitive. And in our case, the coating materials, these are carbon nanotube. Carbon nanotube are nanomaterials that came up 20 years ago about, and that have been extremely often used for sensing application because they are very sensitive to the environment. And based on these guys, we've developed a couple of years back a series of chemicals that we patented to make nanotube sensitive to water quality parameters. So now you have to go from these new materials to a sensing device that can be used in India. So when we put out the patent in 2017, the classical technology to do that was in silicon chip technology. Silicon chip technology is extremely powerful in your cell phone when you can do very compact devices. It has, however, a cost limitation when you have to make centimeter square devices, which we need for this application. It's relatively expensive, 10 euro per square centimeter. So the first design in Lotus came out from a previous European project targeting the European market, and it was not a problem for the European market. When we put down the numbers in Lotus and we thought about the Indian market, we realized this cost, the cost of the sensor chip, when you add all the costs that it adds up for assembly and so on, the cost became not affordable for the Indian market. And at this point, we came up with an idea, which is to move to plastic technology, to printing technology on flexible substrate. And we had a new concept, which is a concept that we're going to produce and commercialize in the next couple of months. So this solution, much less expensive. Let me explain a bit what you're seeing there. So this is 2.5 centimeter per 2.5 centimeters. And this dark stain you see here, these are carbon nanotube. And this is a sensor array that contains 12 sensors for chemical parameters. And we're targeting 3 different parameters in this chip. On top of that, you're measuring temperature and total dissolved solid via water conductivity measurement. So these guys, you need to make it speak. So you need to connect it with electronics, packaging, so that you can use in real application. And that's what you have here. You have the Lotus node. And then from there, this is a sensor that you can put in a pipe. This is not just a mock-up image. Right now, we have a sensor running since September in a water loop that we have in Paris, a 40-meter water loop at 1 bar, 0.3 meter per second of flow. And the sensor here, you see it here, it's inserted here and it's running and measuring parameter of the water there. So overall, the architecture of a Lotus sensor is to have this sensing head, now in plastic. You connect it to electronics. And then the digital information that you get is managed by the Lotus box, which is solar powered. So can be completely wireless and send the information by multiple channels, either LoRa, Wi-Fi, 4G, to the end user. And the end user gets this information through any means that we need. For instance, we have a mobile app. We have cloud-based dashboards, and we could put that into any SCADA that you want. These are the parameters we target. What is important to us is to have a first platform that will be that is minimal for everywhere. That's what you need everywhere, be it in Europe or in India. And this first platform, going too fast for me. This is these four core parameters: temperature, pH, chlorine, total dissolved solid. What we plan in the next coming months is to move into arsenic and fluoride. On top of that, everyone needs information on the quantity of the water, which means pressure and flow rate. Toward that goal, we don't need to make new sensors because there are a lot of sensors available on the market, but the Lotus box allows to connect external sensor as well. The sensor, as I mentioned, can be installed in pipe or can be installed through a bypass. This is very important because the use cases are so different than what we are proposing is a solution where you don't have to reinvent the installation each time. You use this bypass system that was actually patented by IITG, and you don't have to reinvent it. This is the bypass that you're installing everywhere. So you don't have to recalibrate for packaging, for installation. You have your standard installation. And actually, we have a testing facility being set up in Udaipur here, where you have these guys, 50 lines next one to each other for mass calibration of sensors. So to illustrate this, I'm going to try to run the video. I don't know if I can run it from here. Someone needs to click on the video on the computer, please. No. This is a test bench that will be used for roadshow. Basically, you take the sensor in that guy and you can present it in Rajasthan. That's planned for end of the month. And then you can present it in Delhi 3 months later. So these are the analytes that we're injecting into the tanker. So you can control automatically what you're putting in. And this is the bypass system with the sensor. Of course, if you want to calibrate and convince your user, you need to compare the value of your sensor with the value that your system is giving. So very quickly, our demo. In the end, what we want to provide is a plug-and-play system with standard installation, very low or no maintenance or recalibration cost that will be affordable for the Indian market. So I didn't scratch out the low cost here. The goal is not it's extremely low cost. The cost is good quality at affordable price. This road brought us to a technology transfer from UniFL, my university, to the company called Hydroscope, which is based in Udaipur, Rajasthan. This was earlier last year, and on December 29, 2023, we submitted 2 patents that are joined between UniFL, IITG, and Hydroscope to push this technology further in the next coming months. You can go see Hydroscope website at the link here. Basically, the story is they want to commercialize the sensor starting from this year, starting beta testing June to September this year, and then ramping up production until we reach next year 10,000 units in a year. This has been a very hard job. We have to transfer technology from France to India. We also have to line up a lot of things in the chain of value because it's a very complex product that goes from nanoparticle-based chemistry to in AI. We were mentioning AI earlier. We do a lot of AI to analyze our data, and we have to bridge all this gap at commercial level. So we have lined up French companies. We are transferring skills to India to produce everything in India in the next couple of months and years. So now Senthil will take over and present to you the application of the sensor in the different use cases.
Well, good morning to all. So basically the application of the sensor in multiple domains, it goes beyond water
can be in a wastewater, it can be multiple application, but we restricted at present part of the scope with the water distribution network and also the water tanker use case. So one of the use cases for a water tanker, so where we have developed chlorinator, electrochlorinator, which can be powered by solar, and in partnership with a German company, etc. And they helped us to develop the electrochlorinator, and this will be integrated with the Lotus sensor, which will ensure that the controlled dosage of the chlorine to meet the water quality standard, which is typically at end user 0.2 ppm. So then another use case we talk about supplying, let's say, pure drinking water when we have a TDS is beyond the specific standard for the drinking water quality. So we are planning to use high recovery osmosis process, reverse osmosis process. So conventionally, if you talk about the reverse osmosis, the recovery is somewhere around 50%. So the objective, and this is one of the patented technology from our group, which can go 80% recovery when we have a TDS of 2000 ppm. So that's the main objective here, is that high recovery, because government is also pushing green RO, so where the recovery should be higher than 60%. So to meet these two objectives, we are planning to deploy these two units in water tanker use case. So we are in the process of integrating with the sensor, and the deployment phase we are planning to soon deploy in actual field. Actually, this system is already fabricated and it is tested in IIT Guwahati. We are just moving the system to the actual field in coming weeks. So the next use case is basically the distribution network. In Guwahati, we have a new distribution network which is just completed for southern and northeast part of the city, which is something like scattering of around 4,000 users in southern east and another 12,000 users in southeast. So these two distribution networks, we are planning to deploy the Lotus sensor. So as we said, we are in the production of, let's say, between TRL 7 and 8 quality of sensor that will be deployed in field in this, let's say, 2024. But since we have not deployed yet, so what we did that we have simulated the network in EPANET, and then we try to measure the chlorine concentration using a EPANET model, and then we introduced a leak, and also we introduced a contamination in the actual EPANET model. And then we have developed the algorithm for the leak detection and also the contamination detection and how to mitigate this problem. So we did a completely a virtual simulation in EPANET, and then we used Fiverr as a platform which is coming from European Union for a smart city. And using this simulation, we were able to validate our algorithm. But once we deploy our sensor, we will be redeploying the same algorithm in the actual field for water quality monitoring and leak detection. That's the plan. So one of the key requirement, for a tanker and also for a distribution network, leak detection, and also the scheduling algorithm for tanker fleets, and also the water quality monitoring. So we have developed the base algorithms and the framework to deploy fleet, water tanker fleet scheduling, and also for the water quality monitoring and ensuring the quality at the end user point. So this algorithm is also, a kind of a collaborative work between a European team and Indian team, and which is being, let's say, tested right now, and we will be deploying it in the actual field. The last use case which we are talking about for irrigation. So in irrigation, one of the main objective is that, how do we minimize the water consumption? And same time, how do we ensure that the yield of the crop is, not compromised? So we did a first pilot in 2023, and we have found, let's say, marginal improvement in the water quality, water consumption reduction without compromising the yield. But however, we are going for a next field deployment in coming season. And we expect that to revalidate and also reposition our sensor to deploy the irrigation use case. So these are the use cases which we have gone through the project. So the main, the thing which we would like to bring out the, let's say, part of the Lotus journey, the knowledge transfer. So we had a collaborative research. To explain this collaborative research, we had a joint student between European Institute and India. So there were a one-year exchange for the PhD student, and who has come back with the knowledge, and then that knowledge helped us to transfer to the industry. And then now startup is taking up the new initiative productization in India. So this is one of the key, collaborative and knowledge transfer takes place. And also we are planning to train few more resources who can go to Europe to get trained on certain key components. Like we use a carbon nanotube based ink, and that ink will be, fabricated in India or manufactured in India. So we need a proper knowledge transfer to that happens in India. Right now, the ink is fabricated in Europe. We started now production locally in India. So at end, we are planning to have a tight collaboration, and then we move into this objective.
So I will summarize here and our Lotus journey, our story. So this is our Lotus project story. And I highlight the work of project. But actually, this story started even before, when we, like 5 years ago, we sit together and we developed the proposal based on two major elements. One, to develop a novel sensor, affordable, right, multi-parameter. And two, to use information provided by the sensor for better water management. So that was like two ideas. And then there was a phase of the beginning of the project. And we all know that it is a learning curve. So this first year we started, so we learned how to work together. Okay. And then challenges started. Then, of course, COVID crisis, we were all affected by it. And I said, fortunately, we did our co-creation workshop just 2 months before. And then during COVID type, labs are closed. You cannot do experiments, you cannot advance, okay, not even talking about exchanges and so on. And then there were development difficulties, where also some approach was changed and so on. But actually, this is normal because we're talking about research, and research means uncertainties. So somehow we are all assuming, like usually, that TRL, technology readiness level, should go high constantly. No, because if this is advanced and their development difficulty, so here the hardware of the sensor was changed. So definitely new tests were required. So TRL is pushed back. But this is, again, this is normal. This is research. Okay, so once this was overcame, these difficulties. So, and this, I would say, is the phase of, adaptation of R&D approach in this case. Then we started to get highlights. Very strong involvement of partners, very motivated by the new development and the new results. Student exchange, something mentioned, that was really major, I mean, instrumental. Okay, this is a PhD student, working for 1 year for knowledge transfer, joint patenting, creation of a startup, really from Lotus. Attraction of private investment. I was there, we was there in the consortium meeting. 7-digit investment, like euros, whatever, dollars is attracted. This is incredible. This is deep tech. This is uncertainty. This is risk-taking. This is private industry. So this is very, very rare situation. And I have to say that, I'll tell later on. Anyway, we have Lotus Box certified. So now Lotus Box has EU marking, So these are all highlights. So that we call now this phase market uptake path. So that's, again, in a nutshell, a story about Lotus project. I highlight project. So where we are now.
You need to conclude.
I conclude so. So where we are now, very strong and clear exploitation perspective. We have different industry involved in the project. Jane Irrigation, Erica Forbes. We have Hydroscope, you saw this is external. We have very deep collaboration. We have a number of lessons learned. I have to say that the road was bumpy, okay? The road was bumpy because we learned how to work together. The practices were not always synchronized. Funding, reviewing procedures were not always compatible. You know, like it was bumpy, but actually we are happy to pass through this, you know, like because that makes us stronger. This also, we will provide lesson learned also for policy making, you know, like so that others benefit from our experience. Just to finalize, so we have set up Lotus Virtual Fair. So if you scan this, you know, this code, okay, this is a 3D environment where you can navigate, you know, like you have video, you can set up meetings, so on. So basically we have like Lotus Book, a Lotus Sensor Showcase. It will be continued permanently until the end of the year. So at least, you know, we have meeting room and so on. So just the final words. I already said that it was challenging. We are happy that we have gone through. We don't want it to repeat it anymore. Okay. This is not the end of the journey. Actually, this is maybe end of the Lotus project in Europe officially, you know, like, but this is the start of the journey, the start of Lotus journey to the market. And we would like to thank the European Commission, the Indian government, the investors, private industries, and the Lotus partners, because together we made it happen. And our Indian partners say all the time, change is the only permanent. And we say, yeah, we say it differently. We say the only constant in life is change. And with this, we start our Lotus journey to the market. Thank you very much.
On the floor here, because it's all different technologies being developed by our colleagues here. So I think it's time that we try to integrate. Please.
Yeah, good morning, everyone. My name is Girish Kale from Veolia. I was looking at that high recovery RO. So could you just elaborate a little bit on that? Because you were talking of 75% recovery, right? So could you give some more insights, like what is the TDS? And
we have introduced basically intelligent osmotic backwash that enables frequent cleaning of the membrane even at high recovery without damaging the membrane. That's basically, you know, there are technologies that are available for intelligent osmotic backwash, but that's expensive process. So we have introduced a few concepts of how to introduce let's say intelligent osmotic backwash with a low, let's say.
No, but what will be the inlet TDS when you talk of 75%?
Up to 2000, up to 2000.
But fundamentally now 2000, 3000, like for example.
In one stage, we are talking about in single stage.
Just that's where I think I wanted to understand. Because now you see plants going up to 90 plus recoveries.
But you have multi-stage.
Yeah, multi-stage.
It's single stage.
Single staging.
With okay. That's what.
Okay, thank you.
I just wanted to know that what do you do with the leachate?
Which leachate?
When you have the
reject.
RO, yeah,
So reject,
leachate,
reject.
What do you do with that?
It's still to be addressed, and we are working out with the client who is going to use this. The one of the plan is that we would like to put another small, let's say, evaporator and make it to be a salt. That's the first solution we are talking about, because it's a small quantity when we talk about the quantity wise. There's one option. Another option is that, you know, we are thinking of, is there any other mode of a valuable recovery with respect to the region? That's another option.
Yeah, that's great. And another thing is regarding the optimization of water utilization for irrigation, you said. And basically you did it by using the moisture sensor.
Yeah, so in this case,
Jane
probably one of...
irrigators are already known They are considered to be pioneer in doing the drip irrigation. They started it, and it is in association with them only.
Yes.
And normally farmers and any other thing, they can make out that what is the moisture level just by as such. So how do you answer this? How do you look into this?
It's very good question. You know, they can assess the moisture in the surface, but when you talk about the root water intake, that's what we have identified, saying that at what depth you need what kind of a moisture. That matters the growth rate and also yield. So our colleague from Technical University Dartmouth is working closely with Jain. So they have developed the first principle model. What should be the moisture level with respect to depth that will also ensure that the required growth and without excess moisturing in the surface. That's the whole part of this. So they have developed a model predictive control that will predict over a period of time horizon, and they decide when to really feed the water considering the weather station information also.
Yeah, this question is to the lady out there. How robust is the beautiful presentation? How robust is the sensor? Have you looked into some kind of reliability, repeatability, and its sensitivity to dust? Because water will always come with some dust and biofilm. So is there some work? It would have been very good for us to. Thank you.
Okay, so that's a very good question, and we don't have all the answer. Last question about dust. That's why we have a bypass. I didn't mention, but the bypass includes filter. So it allows to filter out the particles, so the sensor is not exposed to dust in the Indian drinking water system.
Yeah, we can discuss. I mean, we have addressed this issue.
I have a point. Just.
Yeah, please.
Issue is that you are ensuring bacteriological safe water by using the chlorine sensor, because presence of residual chlorine will indicate it is pathogen free. But the issue is how you are ensuring the chlorine demand at the site. Whether this mechanism are you incorporating here, chlorine demand? Because chlorination is depending upon the chlorine demand.
We are mixing here two different factors. One is the sensing component. Another one is a chlorine demand. So the chlorine demand is basically we need to come up with the appropriate controller, and that should ensure the chlorine demand. It's basically a dosage control based on the feedback we get from the sensor. So of course, IIT Bombay, Abhilasha is here. That's her core competence. She has developed already an algorithm that can calculate based on the chlorine sensor measurement what should be the chlorine demand, and we can supply.
Yes, kindly do that. Okay, thank you.
So our online friends are there, Professor Mohan Kumar, Professor Venkat Mohan.
Yeah, thank you, Professor Prasad. Can I come on, Professor Prasad? Yeah. Thank you very much to the whole team, Lotus team. Very nice presentation. Only
can you be a little louder, Professor Mohan Kumar?
Okay. Am I audible now, sir?
Yes, sure. Please.
Okay. Thank you. Congratulations to the Lotus team. Excellent presentation. My only question is, it's almost a continuation of what Professor Chanakya was asking. We understand that the lab setup, all the calibration has been done. And obviously in the field situation, when it comes the sensors, obviously there could be a lot of deviations. How it is planned to be handled?
Yeah, I said, changes only the permanent. We have to adapt the requirement, whatever comes in the field. We will. So we are here to say this is the final product. We have to address many challenges which we are going to foresee in the field. We accept your valuable suggestion.
Okay. One more question is my last question, because others will be there. So you already said that many things are developing almost to the real situation. Is there a plan to develop a digital twin model which will account for both the hydraulics and water quality, especially in a distribution system, which is very much needed in our setup?
Yeah, so I hope Professor Guri was there, then he would have said. One of the Professor Guri's student is already working on digital twin, which will combine both hydraulic and also even they are talking about the AI model. So that will help us to really do a better job when it comes to the hydraulic and also the water quality. We are in the path, and we need this solution to move forward with this sensor to the commercialization, which is must. We agree.
Thank you.
Thank you. I think maybe we have heard about the Lotus story. It's really good. I mean, from various points of view, the two basic components is the development of the sensor, and the second component is how best can you really utilize it in a real ground situation. So in this, I think one component which when you say that you are going to utilize your sensor in the agriculture field, I think we have to remember that there are other things like nutrients, etc. So they need to be an integral part of the sensor. And the perceptions or the proposals very clearly say that it looks into the pesticides, fertilizers, so many other things. So I'm not expecting an answer at this stage, but the parameters that we have been measuring are the parameters which you can measure otherwise without Lotus sensor, right? So keeping that in view, I think it's time that where are you and then how fast would you be able to cope up with that particular situation is the only thing which we want you to really think about very seriously. And we don't, maybe I think she's ready to, the architect of the sensor is ready to give an answer, but okay, please.
So the key point in the sensor is having the reliable platform. The chemicals we have, dozens of chemicals. We have a model to prove that the chemical works. I have chemicals working for glyphosate, for instance. So we have the chemicals. What the key is that the platform can be productized. Once you have a platform, switching one ink by another is easy. It's not the problem. Adding a new ink is easy, so adding a new parameter is easy. So our job, once the platform is ready, you want any parameter, we do any parameter. That's what we want to do, and this is now doable. That's the story.
Yeah, I mean, you see, we are happy. We are at least convinced that things can be doable. That part is very clear. But please remember, the freshwater system, which we are really talking about, you have a phase where the treatment has already been done, right? So that's where perhaps the requirement of the other sensors, which will look into the geogenic crop contaminants and the other things, will not arise. And more so, the so-called emerging contaminants, which are just disappearing without the knowledge of anybody else, would also be another serious problem which need to come. So, but the journey, as you said, what you have done is extremely good. Absolutely, there is nothing, no comments on that. So you have done a wonderful job. But in ground reality, if we are really claiming that we are addressing the challenge, the reality is the challenges are slightly different from what we have. And I'm sure you are prepared for it. And we expect you to reach that goal very soon. That's all what we wish, right? And time is certainly is only 4 years, out of which almost 2 years is gone for everybody. We are all aware of it. But at the same time, I think the collaboration fruit should be seen as soon as possible, at least in the next 1 year, right? So it's true that you have the inks ready, but it's also time to test them. And again, we have to test the robustness. Things are going on. We know pretty well about what's going on. But in this, I think you are certainly on the right track. And absolutely, we try to see the end of it as soon as possible. Right? Thank you very much. So I think thanks a lot for the wonderful teamwork that you have really done. And I think it's now maybe we'll quickly go to the other project, Pani Water. Yes, sir. Sir, one small request. Can we have photographer? Can we have a photograph of all of us within the room? Professor Varshney would be leaving just for a minute. No, please. Yeah. Here itself, we can assemble somewhere, right? Yeah. We'll go up. Please. All the participants are requested. Yeah. Please, all of you can come here so that we just have a quick photograph.
So we have something. Yeah. Yeah, voilà. What time are you leaving? Thank you.
Allô, comment il s'appelle? Voilà, elle est Ah oui, ça. Oh, it's okay.
I'm going to sit down now. So I can see this. Is that okay? When your time comes out, so I'll stop this.
Okay, please return to your seats. So now we have all stretched our legs. We can go back to the scientific work, and we will see now any water. So Professor McGeegan and Dr. Rodapka, please.
Thank you. Ladies and gentlemen, my name is Professor Kevin McGuigan from the Royal College of Surgeons in Ireland. I am the European coordinator, and this is my colleague, Dr. Rita Dodabka from CSI NERI, who's the Indian coordinator of the Pani Water Project. What is that? Okay, sorry. So, the objectives of the Pani Water Project were to develop, deploy, and validate 6 prototype technologies for the removal of contaminants of emerging concern from wastewater and drinking water. The consortium consists of 18 partners, 12 from Europe, 6 from India, and that consists of universities, research institutes, social enterprises, SMEs, industry partners, and NGOs. The 6 technologies were divided equally: 3 drinking water technologies, 3 wastewater technologies. The drinking water technologies were, first of all, there was a filtration, adsorption, and ultraviolet disinfection unit, the FAU, which was developed by BITS Pilani in Goa in collaboration with KPPL in Hyderabad. The transparent jerry can, which was used for solar disinfection at the household level. That was a co-designed project between RCSI, Bucks University, University Rey Juan Carlos, Maynooth University in Europe, and Devalt, Tara, and CSIR NERI in India. And finally, a solar-powered electrocoagulation, oxidation, and disinfection unit, which was developed by Team Trust in Auroville in India. So our filtration, adsorption, and ultraviolet FAU technology was developed by Professor Halan Prakash in BITS Pilani in Goa and Mr. Gupta from KPPL in Hyderabad, who manufacture the UVC light-emitting diodes. The designs fell into two forms. We had a kiosk, which could deliver 300 liters per hour, and then a smaller household wall-mounted unit, which delivers 30 liters per hour. Essentially, the technology is the water comes in, it's filtered through a sand filter, through an activated carbon filter, and then it goes into the unique innovation, a chamber in which we have an array of UVC light-emitting diodes emitting at 276 nanometers. The kiosks were piloted in the canteen in BITS Pilani, Goa. It's been there for over a year now. And what we have are long-term stable UVC LEDs affecting the disinfection. You can see the wall-mounted FAU unit for household treatment here. It's the same basic design, but on a smaller scale. Now, the advantage of this and the kiosk is that they're using UVC light-emitting diodes that are manufactured in India, and these take the place of, they provide the ultraviolet that currently other technologies would be relying on mercury discharge lamps to provide. With mercury discharge lamps, there's the whole problem of mercury contamination and the disposal.
Sorry, we are seeing only the first slide, sir. We are only seeing this first slide outside. Sorry.
Okay, thank you. The desk are looking at that now because they're advancing here.
Yeah. Now we can see the sixth slide. It has moved now. Yeah. Thank you, sir.
Okay. So this technology, we have a patent submitted and approved for BITS Pilani, Goa, and KPPL in Hyderabad. So as I said, the advantage here is we're using UVC LEDs. They're less problematic than the mercury discharge tubes, and there's legislation in place where they want to phase out the use of mercury discharge tubes in these UVC disinfection units. The unit cost at the moment is 13,000 rupees, and that's a little more expensive than its competitors that use the mercury lamps, but we feel down the line with a few more phases of design, that unit cost will come down. And even though we're currently competing with the mercury lamp using systems, ultimately they may become collaborators or joint investors. So there's lots of opportunities for this particular technology. Now, I've just advanced the slides. Can the people online see the new slide, or are you still problematic?
No, it's still in 6, slide number 6. Maybe you can go ahead. I think there's some tech issues. Those guys have to sort it out, I think. Yeah.
Okay, then. So the second technology is electrocoagulation, oxidation, and disinfection. This is a technology that was developed by our partners in Team Trust in Oroville, and it's a drinking water technology designed in the form of a kiosk. The basic technology is, apart from the standard filtration aspects, they have electrodes of different metallic substances, and then when you apply the voltage, that brings the arsenic, the iron, the fluoride, precipitates it out, and that can be removed in the form of a sludge. As well as that, there is a disinfection unit, a chlorine disinfection unit incorporated. So we're removing the arsenic, the fluoride, the iron, and we're disinfecting the bacteria. The kiosk has very few consumables. The electrodes need to be replaced every 6 months or so, and the electrolytes when they're depleted also. The unit cost is 450,000 rupees for a kiosk, but again, that will come down with further phases of design. Not advancing now at all. Hello? Okay, here we go. So the final drinking water technology is a 10-liter transparent jerry can. And I know what you're saying, a jerry can's not a technology, it's just a container. But the intended use of this container is for solar disinfection of drinking water at the household level. Now, this is something that we've looked at in previous projects. We know solar disinfection works at small volumes. We wanted to look at it in larger volumes. Originally, we planned on producing 20-liter solar disinfection jerry cans, but our stakeholder engagement meetings with the people in Bundelkhand, where we planned to do our pilot trials, they indicated that they would much prefer 10-liter jerry cans. So that's what we ultimately fixed upon. We produced 10-liter jerry cans based on a design from Bucks University, but we manufactured them in India with local manufacturers provided to us by our Indian partners, Dara and Devalt and Tara. Our initial results were very encouraging because we were able to prove the concept. We can absolutely see that 5-liter transparent jerry cans, when you fill them with contaminated water, we can inactivate that. We can inactivate the bacteria, the viruses, and the protozoa. We also found that there was no need to go to extraordinary lengths to produce transparent, high optical transparency jerry cans because translucent jerry cans were just as effective. Our long-term toxicity studies on the jerry cans revealed no problems with chemicals leaching from the food-grade polypropylene. And our intention was these kind of containers could be used by the community in times of emergency and disaster. They would have them in their household. However, to every story, into every life, a little rain must fall. Unfortunately, we found that the transparent jerry cans, the early prototypes, were not very robust. They did not withstand the environmental conditions. They became very brittle after only 9 months use. So in total, we've gone through 4 different prototypes where we've looked at different container materials. And we've come to the conclusion that, well, if you add additional UV stabilizers, they become much more durable, but unfortunately they lose their microbicidal efficacy. So at this point in time, we feel polypropylene is not the material that we were looking for. We're now looking at a different set of materials, probably polylactic acid from the perspective of more environmentally sustainable, or polymethyl methacrylate, which we know is very durable. And also we think maybe rotary mold manufacturing, fabrication would be better than the blow mold. So unfortunately, since we were unable to produce a sufficiently stable prototype for the jerry can, We were unable to bring this to the field. And while personally that's disappointing for me, it's even more disappointing for our social science colleagues because they put in an awful lot of work in Bundelkhand, talking with the community, preparing the community for this, running workshops on household water treatment. So there's a huge amount of work, effort, and time that's been put into the social sciences aspect, which unfortunately are not reflected in this technical demonstration, but actually makes up for an awful lot of the work that went into the project. Now, they were involved with some of the wastewater treatment projects, so Dr. Dodabka can speak to those. And I'll hand over to Rita now.
Thank you, Kevin. At the outset, let me thank Department of Science and Technology for funding this beautiful project with the EU Commission. And I will repeat what our Lotus colleagues have said, and it has been a wonderful journey. And a similar graph, you would say, we have gone through during the COVID times and overcome the challenges. So here now, after the drinking water technologies that Kevin has presented, we'll present the wastewater technologies. And here we are actually talking about contaminants of emerging concern. And when we talk about contaminants of emerging concern, it can be endocrine disruptors, it can be pharmaceuticals, it can be personal care products, it can be antibiotics, it can be steroids, hormones, and it also includes antibiotic-resistant bacteria and antibiotic-resistant genes. Now, before we target any removal studies, we do the profiling and quantification to actually understand what are the contaminants present in our India, the treated wastewaters, which are going to the surface water bodies indirectly or directly, and they are being discharged. So the first task we did was the profiling and quantification, and we have about, okay, we are still at the first slide. So our first objective was profiling and quantification of the contaminants of emerging concern. And then we have the demonstration of a multifunctional reactor that is to the scale of 50 meter cubes per day with a stakeholder that we identified at Nagpur. And then we have the design and demonstration of a tertiary and advanced treatment system, which we have demonstrated at a 2 meter cube per day. This is a solar-driven process at Nagpur itself, at a urban wastewater treatment plant. And the last is at a lab scale, we have developed a photo-electrochemical system, which is also solar-driven PV integrated for disinfection and removal of contaminants of emerging concern. So data on the occurrence we have published in Journal of Hazardous Materials, but our reports will have more updated data where we have given the most, because when we talk about contaminants of emerging concern, it's like a spectrum of contaminants, and you can't study all at once. So you have to find what is ubiquitously present in all wastewaters, and we take that as indicator contaminants, and that is what we have studied here. So you can see that we have identified about 65 pharmaceuticals, 14 antibiotic residues, 20 pesticides, 3 sweeteners, apart from the antibiotic-resistant bacteria and genes, which are presented in this publication and also in the report which we have shared with EU and DST. So the concentrations are also not very low. It is 0.4 to about 1,340 micrograms per liter. And ARG are the gene copies which is identified in the effluent. And though there is a reduction from the untreated to treated, but the resistant genes, they are still existing. And as you know, the horizontal gene transfer can take place. And this is what we target when we are doing the removals for antibiotic resistant genes. So we find that the results we have obtained will help evaluate health and ecological risk associated with the presence of CECs, and which also will help in framing future policies, since Pani Water Project is talking about removal technologies. And unless we have technologies which are going to be robust or can be practiced as an advanced tertiary system, you cannot have policies which will have the regulatory concerns. So next. Will you do the next? Okay, so this is our first prototype which has gone on the field. Can you press the play also? Yeah. So it's a dual-step multifunctional reactor, which is a combination of the optimized physicochemical process, treatment, and the advanced oxidation process. So this is uniquely designed to cater to the needs of Indian treated wastewater. What we are taking is the inlet to our multifunctional reactor will be the outlet of any conventional treatment system, which will consist of the primary and the secondary treatment, and possibly a tertiary treatment, which includes disinfection. So this reactor dynamics, the fluid dynamics is unique, and the residence time that is designed allows complete mixing of effluent and with the oxidants, and it gives full utilization of oxidants with optimized reaction times. It has minimum maintenance and low electricity consumption and a reduced sludge volume. What is the innovation here? It's a patented technology of aquasoil. They have a world patent, but we in India have worked on the conditions to make it, we can demonstrate to a scale depending on the inlet qualities of the wastewater treatments here. So it allows simultaneous use of liquid and gaseous reagents. It has a low footprint. It has, because of the low footprint and the accurate dosing of the chemical reagents, we have a reduced operating cost, and it can be retrofitted with any wastewater treatment systems. Accurate dosing with appropriate sensors can be integrated. Next. So as I was saying, the MITUS technology, which is patented, it allows simultaneous dosage of multiple treatment reagents in multiple phases, and it achieves high mixing rate because of the high pressure, and it can be integrated with the small footprint, and it is proven at full scale for tertiary treatment in India and in Italy. So this is our demo unit, which is at the Vayu Sena Nagar, which is the Air Force Maintenance Command in Nagpur. We were very much welcomed by the Air Vice Marshal, who was very much interested in environment. And since they are using their water for irrigation inside their campus, he thought it is a very good technology because it contains advanced treatment systems. So what is existing over there is the moving bed biofilm reactor, a clarifier, and a dual media filtration. The outlet of this becomes the inlet to our system. You can see this is the multifunctional reactor followed by the lamella clarifier, and what we get out from the clarifier is an irrigation grade water resource for reuse, and that is the circular economy solution that we are looking at in Pani Water project. Now, the capital cost for system integration in India was about 2.25 million. The capital cost was 0.46 million euros for the MITOX, but this can be substantially brought down if manufactured in India. The operational cost was coming to about 0.15 million per year in Indian rupees. And there is a scope for revenue generation systems by the water resource recovery. The second one was a much simpler technology, but then it is highly focused on only removal of contaminants of emerging concern, whereas the previous technology also takes care of the residual suspended solids, and both are actually removing the CECs and the antibiotic-resistant bacteria and chains. So this plant is, again, can you play that? Thanks. So this is a plant we have put at the Bhandewadi wastewater treatment plant. Bhandewadi wastewater treatment plant already sells its water to the thermal power plant, which is at Khaparkheda near Nagpur, which brings Nagpur into a very green in the fuzzy logic map for wastewater reuse systems. And what we have done is a process optimization for achieving maximum removal of contaminants of emerging concern and controlled dosing. It has controlled dosing of peroxidant, and the unique upflow design ensures maximum exposure to the UVC, which is over here, to achieve the optimum performance. And of course, it is the continuous mode of operation. So we have nearly 80%. Why I have put this? Because I know that in Swiss regulation or in the Europe, you have this 80% reduction of CECs for some 6 contaminants of emerging concern enlisted already. And we have seen resistance against ciprofloxacin and some antibiotics reduced significantly after UV treatment. And we have a decrease in the count of indicator bacterial load. And qPCR also shows a decrease in the number of antibiotic resistant genes in effluent. So coming to the last technology, this is a photoelectrocatalysis water treatment, and it is, of course, solar PV based, powered. And the advantages of this is it generates oxidating agents that work against microorganisms and chemical pollutants that current technologies cannot remove in the conventional system. It does not require addition of chemicals. This is a concentric, design of the electrodes, which enhances the lifespan of the oxidants produced. And this can operate at very lower current and voltages and has a very low energy consumption. And this is currently at TRL4, and some pilot scale studies we are conducting in Niri in partnership with Worcester University at UK. Of course, we need more work to evaluate the lifespan of the system, and thus effective cost per liter has to be commuted. Okay, going to the technology readiness levels, we have seen the solar power UVC plant, which is at TRL6, as well as multifunctional reactor, which is also at TRL6. The EOD is at TRL5, and it's a very good technology, as Kevin has said, that it has simultaneously, it can remove arsenic fluoride and iron, and the also contributing, also have disinfection for drinking water. Then we have the PES system, which I have just shown. It is at TRL4. The transparent jerrycan, we are going to have to redesign it. And the FAU, which is ready to launch in the market, which we'll be talking about tomorrow. So we have the IP readiness. The multifunctional reactor is decision to protect is already there. It has an IP, and we are in discussion with how we can work jointly. And the other FAU is already applied for patent for the LED component, and the market readiness is very high. As you can see here, we are already at the end users. We need distributors. And of course, this is the projected CAGR for the water sector in India. Thank you.
Thank you very much. Yeah.
One issue with respect to the EOD that you talked about, say removal of fluoride, whether the alkalinity will have any influence with respect to that electrocoagulation. The another issue is about the removal of arsenic. You have mentioned whether arsenite and arsenate proportion in the water will also have certain impact. And finally, whether any filtration arrangement is there with respect to EOD, because some colloidal particle could be formed after electrocoagulation. So therefore, certain filtration arrangement should be better. I don't know whether it is there or not.
With regard to the alkalinity, the impact that we've seen there is it affects the duration before when you have to replace the electrodes. So there is an effect there. You're going to say something on the...
Yeah, the alkalinity will definitely play a role because the electrodes will, yes, so that is there. And the filtration, sir, we have a filtration system post that because obviously there will be colloids and, some precipitation because of the electrochemistry of with the electrodes. So that filtration system is there. Yes.
You mentioned two modes of removal of the emerging contaminants,
Yes.
but didn't mention how it works. Is there a general principle on which there are two different principles, one with UV and another with electrooxidation? Any quick suggestion as to how it is working so that we can think of how do we take it forward and what are the conditions in which this will be viable in India?
You're talking of drinking water?
Yeah, the two, both, in the wastewater treatment.
Wastewater treatment. So what we have done is so many years of research we have tried to translate into technology here because this is a homogeneous advanced oxidation system which we have worked on. There is a lot of work, but this is the first time we have tried to demonstrate at a pilot scale this technology. So what it does is when you have this combination of gas, we have used ozone here, and some peroxidant in presence of them together, they have the capability of generating hydroxyl radicals, which have a very strong oxidation potential. So that oxidation potential radicals are going to react with the residual micropollutants. So that's the mechanism, both in the photolytic system and the multifunctional reactor. We have used coagulant for multifunctional reactor because we find residual suspended solid, Nadeem will know this, suspended solids also there in our tertiary treated effluents, especially in decentralized systems. If you go to a centralized wastewater treatment plant, like I said, in the Bhandewadi, which they were selling it already, where revenue generation is there, then the quality is much more maintained. So the financial model that we need for the operation and maintenance will always be good if we can generate any grade water as a resource. Maybe what we have targeted here is irrigation, because we know that contaminants of emerging concern have toxicity related to them. And also that irrigation needs to be used for agriculture for food crops. And there are so much work which people have done about bioaccumulation of CECs in food crops. Yes, sir.
Thank you. Thanks. You already answered some of my questions. I just wanted to know one thing. You say that you have either PP vessels or some other containers which are exposed to the solar. No doubt you are having some level of the disinfectant, but in the process, don't you find some biofilm formation?
We're not adding any disinfection.
No, I understand. The solar itself will carry out the disinfectant activity, but I was wondering if you keep it for a longer time, there is a probability of having a biofilm formation along the wall.
Yeah, we've put these out for up to 9 months, and we don't see biofilms being generated.
Yeah, that's something great.
I think the solar flux is so big that it really works against the formation of these things. When we implement them in the field, we have a regular maintenance routine for washing them to make sure that whatever does build up is removed. But it's not a problem that we've seen either in this container or in previous studies.
Also, sir, in the SOP, we say don't store it in the same. So the water is always removed and dried. It's shifted to a stainless steel.
Okay.
Which is why the biofilm is.
No, I'm talking about the container which are exposed to the solar.
Yes.
So there they are likely to, because over a period of time, it will have a tendency to form the film. That's what. Another is regarding the emerging contaminant in both wastewater treatment and others. You are able to cut down the microbes, no doubt, because of the advanced oxidation and other thing. Does it really take care about the pesticide? Does it really take care about the what you call personal care products and pharmaceuticals?
Yes,
are they are cutting down to significant level, or it cut down completely?
With the quality that we have seen, you must have seen, I have put the performance parameters. So there is that limit which the NGT we have, 50 COD, 10 suspended solids, 10 BOD is the control parameters. So if we have that, we have already got about 75 to 80% reduction in the CECs as confirmed by LC-MS analysis.
That's basically because COD, BOD perhaps may not contribute much in terms of emerging contaminant.
Right.
So those constituents should be able to get removed during the process. That will make sense. Thank you.
Yeah, Bernard, can we ask a couple of questions online by the time you reach to the people?
Yeah,
Samrat,
please.
can you try some questions online now? And please ask the question very concise, not comments.
Yeah, we have Lena Thomas, who would like to ask a question to the presenters. Lena, please.
Yeah, thanks, Samrat. Hi, everyone. This is Lena Thomas from Global Business Inroads. We help with technology internationalization and commercialization. A quick question. How ready is this tech to be used by corporates and SMEs in India, given that corporates and SMEs face problems with water quality and wastewater treatment and need these solutions? So how ready is it to be used? And two, have you done a competitor analysis to compare with other existing technologies? Thank you.
Well, two of the technologies that are market ready straight away, the MFR and the FAU, they're ready to go. You'll see in the presentation tomorrow from Fabio Ogolini where he's done the competitor analysis. So we don't see them as competitors, we see them as possible collaborators in the future.
Absolutely. I'm talking about competitor analysis with existing technologies, that are there in India and Europe.
Yes, we are talking about competitive technologies, and there is some work done on both the technologies, multifunctional reactor and FAU, and we have that report, and I think we can individually share that with you when required by you. So our mail IDs we can share.
No, great. That would be very helpful, given that there is a big need also in corporate CSR in India to uptake these kind of solutions. That could be a very big opportunity for you.
Thank you so much.
One more question, and then we have to all the questions we can ask during the tea. Yeah, please.
Thank you for the wonderful presentation. I just want to look on the application side, like Ministry of Jal Shakti. The Ministry of Water Resources of Government of India has its two major initiatives, Jal Jeevan Mission, aiming for the quality drinking water to all the households in India, and then National Mission for Clean Ganga, where a lot of things are happening towards sewage treatment plant and improvement of the wastewater infrastructure. And the team has showcased, like you have done a kind of intervention in Nagpur with the help of the Air Force. So if we look like the needy is involved and there is a backup of DST and DBT. So the initiative of the government of India are actually like a real, the fertile ground where these innovation can be pitched in to disseminate the success of the innovative technologies obtained by the project. So whether Ministry of Jal Shakti is being means approached, or there is a plan, or how you, because they will be the one, those who can be really helpful for the uptake of the technology. Thank
Yes.
you.
Thank you. NIRI works in very close association with the National Mission of Clean Ganga. In fact, we have already got a project where we are evaluating, so we have a surveillance of antibiotic resistant genes and bacteria. Whole CSIR is involved in that project. So yes, we can showcase this immediately, because what we see potential of MFR is not only in sewage per se, it is also going to be very, very good for industrial wastewater because of the low footprint that is required and the low operation cost. So yes, we can approach Ministry of Jal Shakti, and I would take DST's permission to do that and create a platform for us to interact with them. Thank you.
So thank you very much. We will have now a break for tea or coffee outside. So let's come back in 15 minutes. 15 minutes. Thank you very much.
The tea and coffee is being served upstairs. Just on, if you go up the foyer, please. Thank you.
Quickly, we will restart, and we will restart with the project Pavitra. And so it's Dr. Mirko Hanel and Nadim Khalil. Please. And I will ring after 20 minutes, so you know it's I feel very free. Please. Please take your seats. Thank you very much.
Let's one. No. The laser. Laser. Yes. Can we start? Let's start. Yeah. Good noon. I am Nadim Khalil, coordinating Indian side, and my colleague
Dr. Birko Haniel is the European coordinator from TTZ Germany, presenting our project Pavitra. Title is Natural and Advanced Technologies for Wastewater Treatment and Reuse in India, supported by DST and European Commission. So the total duration that was envisaged was 60 months, and with total outlay 2.5 million euros from European side and 7.32 million from Indian side, supported by DST. So we have a rather, it is big consortia, comprises 22 partners, 10 from Indian and 12 European partners. So, and it consists of not only RTDs, but also SMEs and few partners like National Mission for Clean Ganga, one of the potential end users of the technologies, interventions that we have deployed and developed under this project. Now, as far as the scope and objective is concerned, mainly it focused on the deployment, development, validation of technologies for water, wastewater, and sewage management in India.
Yes, as we would like to show you the results, I will try to be really brief on this one. We have selected technology based on factors like costs, efficacy, and how fast we can adapt them to the Indian conditions. We're focusing not only on nature-based solutions, this was one of the main focus, but we also added high innovative solutions for treatment, for rainwater, for drinking water. The main focus, and I think this one is one of the key points of our projects, we're talking about 14 pilot systems. 12 have been already installed and are running. We will show you later the results and the status of the art. And then, of course, the step road to the market. We have companies which are only joined our consortium under the conditions to be active in the Indian market. And we are now in the phase of signing agreements, protecting the knowledge, and trying to roll it out. But this one, in order to do so, we have separated and we have installed several training workshops. We have organized a matchmaking tour. And of course, we are using the technologies installed on site to show interested clients and partners the systems and technologies. I will come later in a summary short bit. We have already 27 letters of interest between Indian and European companies for the technologies. And I know that this cooperation is going on also behind and besides the actual project.
Now, as far as the prototypes are concerned, in total, we have 14 pilot plants that we have installed in India. And we have a bouquet of technologies ranging from natural treatment processes to advanced technologies or advanced methods, including sludge management. So Aligarh AMU, from where I belong to, has done 6 pilot plants at Aligarh. Like we have done sequencing batch reactor process, that is a modified form. And it is basically a rich water SPR, we call it. Then in Aligarh, we have done French reed batch system, which is a natural process. Then we have also commissioned HRAP, high rate algal pond system. So this is also a very new concept, and we are taking the use of microalgae in the removal of pollutants from the sewage water. Then we have done SRP, which is really of great interest, particularly from Indian context. So that is short rotation plantation. So we have used bamboo, poplar, and willow or an area of about 7,500 meters square in Aligarh, and we have results of that prototype. Then ISM Dhanbad has done 2 prototypes. One is the rainwater harvesting for one of their hostels. It is a field application. And another prototype is the optimization of the existing sequencing batch reactor, the automation of this sequencing batch reactor to enhance its efficiency. Then SIU Pune, Symbiosis University Pune has done 2 pilot plants. One is ECL2 for water treatment. This is also a real field application for one of the villages, Lavale. And another one is within the campus, that is the sewage treatment plant, and the technology is anaerobic baffled reactor, followed by constructed wetlands. This is done by SIU Pune. Then IIT Kharagpur has done oxidation unit. This is mainly addressing hospital wastewater for one of the hospitals within the IIT Kharagpur. And they are using like a combination of MBBR, this moving bed bioreactor technology, wetlands, and then finally oxidation. So oxidation unit, it has been like the technology has been given by one of our partners from Germany, Otacon. Then Niri Nagpur has done 3 pilot plants. 2 are already installed. One is still in process. The 2 are MBBR and SAF. Both are working, commissioned, and the capacities of these plants are 100 meter cube per day. Hope all are covered. Yeah. So this is again description of each pilot plant that we have done under this program, and TRL labels are also given against each of them. So if I go one by one, this electrochlorination for decentralized water disinfection, this is basically TRL9, and the capacity is 300 meter cube per day for one of the villages near Pune, Lavale. Then anaerobic baffled reactor followed by constructed wetland. This is within the campus of the SIU, 50 meter cube capacity, and the treated water is being used for irrigation, like they are doing mango plantation and maybe guava. Mugda is here, so she can elaborate. Mugda, please come over here. Where are you? Please come. Then third is rainwater harvesting. This is also very novel concept. One of our partners from Germany, Creta. So they have basically been instrumental in developing this technology, and we have implemented in IIT Dhanbad for one of the hostels. Then sequencing batch reactor optimization at IIT Dhanbad. This is also TRL9. Rich water sequencing batch reactor. This is capacity 75 meter cube per day. This is also commissioned at Aligarh. And why I'm calling it rich water SPR? Because we have targeted to retain the nutrients in the sewage and reusing those nutrients for irrigation purpose. So as far as the BOD COD is concerned, that is almost eliminated, but nutrients are retained. Then high rate algal pond system. This is also in Aligarh. This is TRL9. Capacity is 50 meter cube per day. Then short rotation plantation. Mirko, please.
Yeah, I think you mentioned it. I mean, it's like we are reaching around 250 to 300 cubic meters a day. This is really running now for 2 years. That means we had the first harvest. we have the results and look quite good. And I will use this one tomorrow as the material for the pitch. That means I will tell you more tomorrow. Okay, yes, I mean, we have the French readbed, and I think Nadim was mentioning already the technologies. I think we have to be careful with the time. Go next. This one. Yes, I mean, the systems, I think we have explained already. We have the fecal sludge and sediment management, 5 cubic meters. I think this one, like the treatment of tricky sludge is an issue which is not only concerning India, but also in Europe. We have many, many problems of handling the sludge. And my personal opinion of just burning in a really expensive way is not a solution. We have installed the moving bed biofilm reactor with 50 cubic meters a day. We have a submerged aerobic fixed reactor with 50 cubic meters a day. What for us was interesting or a challenging point is if you see here the capacities and the capacities in the proposal, we doubled or tripled the capacity due to the slightly pressure of DST, but we are really proud that we finally did it. Yes, the results are now really needed to get documented. Of course, we are not in the same status of results. That means we need more time to really work it out. Yeah, then we have the fecal sludge and septic management. This one is in the process of getting tendering process. Yes. And we have the toxidation unit with 3 cubic meters a day. And here we are still also in the process of tendering. I think we're done, right? Okay. You want to? Yes. I mean, this is you would like?
This is the rendered image of the facility that we have developed at Aligarh, and we say it now research station. It not only like contain Pavitra pilot plants at Aligarh, the 6 new pilot plants, but also the pilot plant that we installed under FP7 program, swings. So it has evolved very nicely, and it is a gated kind of compound, and we have existing STP from where we can always source sewage, because that is really a challenge otherwise. So you can see all 6 pilot plants that we have installed in Aligarh at this particular facility.
Yeah. Yes, and as we're talking about results, just shortly, we actually implemented 19 international workshops and training sessions. We have now concluded 22 Master of Science and PhD theses, I think more than we actually promised in the proposal. We have 16 articles published instead of the 8 promised because we had really active partners and also a strong interest from the client side. Yes, we did the colloquium of stakeholders. And I think what is really important for us is this 27 letters of intent from Indian and European companies, because this is for us more or less the first step into the market. And yes, based on these letters now, the cooperation is going on. The European side is ending by the end of January, but we are now discussing on different funding schemes, how to continue with the cooperation. The demo sessions and the demo sites are the key in order to bring potential clients and potential multiplicators to the site and to let them know about the system. And we are discussing also ways of using the systems for training. And there are many ways. My personally wish would be to have like regional or national training centers using all the demos for training experts from the municipalities to know what is about it. Because, I mean, if you just check in all the projects, how many systems have been built, established, but I doubt that we get this across India. That means this kind of training and capacity building must be one of the key stones in order to roll out the systems to the markets. Yes, and I think the reports are clear. I will go for one important point. The LCA, we did for 5 of the systems already LCA, and also like a cost-benefit analysis. We focused on the high-rate algae pond, on the short rotation systems, and on the constructed wetlands in order to get a clear idea what it really costs. And tomorrow also I will show you figures in the pitch, and we believe that some of the systems are really ready to be marketed and better actually than the systems we find already in India. What is not coming now? The sustainability question is we have to share the results with stakeholders and with clients. We have to sustain the prototypes. And this one is important that the Indian partners get the resources to run the prototypes, to run the systems, and to get the data we need. We have to multiply the technologies. India is really different in terms of climate, regional conditions. And therefore, I would like to multiply the systems in many regions in India. And for us, the last point, which was actually mentioned by our Indian counterparts, is we need listing. Because if a municipality would like to use one of the systems and we don't have an official listing, they will not do it. That means the question is, how do we get a fast approval of the technologies from the official Indian side? And then I mentioned already the point of establishment of national regional training centers for nature-based or, let's say, alternative treatment systems. Now a really quick wrap up, just to summarize it, 14 technologies installed. We are serving more than 50,000 people in different locations in India. We're treating 1,500 cubic meters of wastewater. We promised 422. That means I think we did quite what was expected. The LCA and CBA completed for 3, but we did in the end 5 technologies. And we have the prototypes ready to enter the market. But of course, now the important part is, in order not to serve 50,000, but 500,000 or 5 million people, we need really a market approach. Yes, we trained the more than 1,500 participants in many workshops for training and awareness campaigns. We have the PhD and master theses, we have the articles published, and we are now focusing on dissemination activities. Deutsche Welle, which is a German TV, or the German TV, was coming actually to Aligarh to make like a documentary, and this one was published in Hindi and English. Yes, and yeah, I think I would like to close now and open the floor for questions. Yeah.
Thank you very much.
In time.
I was even surprised, sorry. So, perfect. We have plenty of time for questions. Yeah.
Yes, it's less a question, it's more an appreciation of what you have put at the last slide, and with the impressive communication effect I was mentioning in my introduction. You mentioned Deutsche Welle and so on. So please be in touch with us. Tanya and Giulio might have the details, but try to help us at the EU office in India, because we need that kind of material, what you have done with Deutsche Welle. We can even reach out the network of European embassies. I can go to the German embassy and so on.
We shared actually in November with you the video.
Yes, yes. And also it's for all the other colleagues in other projects, I see it was interesting when you mentioned link with master students. I am in charge, as part of my job, not only science, but Erasmus. I am in charge for India of the Erasmus program. So we are promoting, it's mainly Indians going to Europe to do master. The reverse is very rare. But if the reverse will apply, if there will be some of you Europeans with a link to the university in the domain of water, you could send your students to India also via Erasmus. So it's something that has to go hand in hand with what Bertrand is doing at the level of projects with the education component. Often there are no link. It's project, horizon, it's Erasmus separate. But if both can be linked, it's wonderful. So it was more a very brief question, if I may, because other 2 or 3 presentations before were mentioning about patent. You didn't mention, is it something that you have looked at also?
So far, we have not thought about going into patents, but definitely we may in coming time you may think of?
Yeah, we had a discussion within the European consortium, and they decided we have 3 companies having quite innovative parts, and they're not going to go for a patent. For a simple reason, if they put everything they have on paper, they're losing more or less, and they keep it as a company secret. And this one is now, let's say, a way many German companies do it, because I don't want to mention any countries close to India, but let's say it makes it easy. If you put everything on paper, you make it easy to be copied. And therefore, the European side in Pavitre, I doubt that they will actually file patents. They have protected with trademarks in Europe. They're supporting their Indian counterparts with know-how, but I don't think they will make an officially patent, because you have to really describe in detail all technical details, and they don't want to do it. Sorry.
Joint publication.
Yes, joint publications between the Indian and the European.
16. Joint.
Yes.
Yeah. And more to come. More to come. Yeah.
There's 3 or 4 which are actually in negotiation right now.
It and then make sure that you replicate it not only in India, but in other places also, which obviously has to be cost effective and technology effective. So from that point of view, I think you have to have a mechanism to do that. So patenting is one component, but certainly patenting is also one component where it will protect you. But what you say is also another way around, but then the publications are also the same thing. Once you make the publications, the technology is out, but you still retain certain of the secrets which you don't like to push it into the market.
In the publications, we are focused on the results.
Yes, okay. That's a very diplomatic way of putting it, but certainly I think it's essential that if you don't replicate it and if you don't demonstrate the cost effectiveness, I think the very objective of this S&T collaboration will not be achieved properly. So you have to have a focus on that particular direction where obviously the technologies, the advantages of technologies had to be spelled out. Whether you provide the details or not, I think this has to take place.
Absolutely. And therefore, the results of our life cycle assessment, of the cost-benefit analysis, we have developed user manuals for all technologies, and they are spread out, of course. The question is, if you really, I mean, if you have like 2 or 3 key elements of the system, which have been developed in the last 10 years, needs to be published, this is still the discussion. But I can tell you, for the 3 European companies, we had a long discussion on that, exactly with the points you mentioned, that we would like to multiply and open access, but I cannot force them. I mean, they decided not to do it, and this is what we have to accept as a research center. But from the Indian side, as there are more research organizations involved, I can imagine it looks different.
I don't have an upfront answer, but I really don't know. It's a question mark whether we are really going in line with the objectives of the entire collaboration or not.
Okay.
So that's something which I think one has to make a soul search and then come up with a balancing application for that somewhere. Otherwise, yeah, because you see, at the end of the day, if you don't really apply it and then at least cost-effective analysis, then the technical aspects, the results, as you said, have been published. So this is the input, this is the output, this is the cost analysis, and the technology costs you this much. And then the maintenance aspects are, these are the details of the maintenance aspects which you need a technician or you will need a technician.
These are all rolled out. These are all published accessible, of course.
Right.
I'm talking about really patenting or telling the core details of the technology or some parts of the technology. Most of them, I mean, if you look at SPR or most of the technologies, I mean, they are not science rocket. I mean, they are like known for 20, 30 years. Some parts are new. And I mean, this is also something in Europe. where companies have learned hard lessons on that. And I cannot really take it in the wrong way if they say, this part we would like to keep. And but I think it doesn't stop the rolling out of the technologies in India at all, because all the informations we need from our cooperation partners, from the municipalities are there. That means there's nothing which can stop the group to roll out the prototypes all over India.
Yeah, anyway, that's fine, but I think the issue of BioCube or something that also needs to be taken into consideration. We'll have a discussion in the evening.
Yes.
The one which has been installed in Jaipur, you see, you have the industry partners, that is true, but the industry partners' responsibility is also the transfer of technology and transfer of knowledge, right?
Yeah, absolutely.
If that doesn't happen,
it does, absolutely.
Yes, if it doesn't happen, then the objective is not fulfilled.
Yeah,
so from that point of view, I think maybe we'll have a separate discussion. It's not the forum where we should really go into those details, but certainly that's what has to be thought of.
Question in the room and then question online also.
Congratulations. I see a number of technologies at TRL 9, right? You have said TRL 9. So I want to know whether you have employed some agencies, third-party agencies to validate your technologies, and which parties are that, so that we can have a database on that.
We have recently signed letter of intents with about 11 SMEs industry, and they have interest to adopt some of these technologies like on a full-scale basis. So still the validation process is going on, and hopefully within a couple of months we may be in a better position to exactly like not to that scale, but maybe bigger than what we have done in Pavitra might be replicated.
Is there any question? I see hands raised. So
would like to point that the disinfection on-site chlorination unit, which is installed at Lavre, so the BDO of that particular village is assessing the water quality at regular intervals apart from what we do. So that can be treated as a validation, and we have the reports from their side also. Yeah.
Samrat, can you open the session online, please? Online questions, please.
Yeah, we have a question from Professor M.S. Mohan. He has raised his hand. Professor Mohan.
Yeah. Congratulations to Pavitra team. Very nice presentation and a lot of work done. And more than a question, it's more a suggestion. These technologies, Nadeem and colleagues, probably should be presenting it to different water boards across the country. There'll be what's called technical committees. It so happens I chair some of them in this part of the country, where you will need to present. Then only what I think your colleague, our European colleague was asking about official listing and all will come up. When you present it, the committees will clear these technologies. And I also see a need for these nature-based systems because of both the Jal Jeevan mission which came up, and more so because of Amru 2.0. We are going to have very large water supply changes in the country, which is already happening. It's going to happen a lot more. Then all the more we are going to have a lot of sewage coming out. And I think that type of treatment need to be done. And very interesting thing which you people talked about, the rich water, where retaining the nutrients. I think there is a lot of discussion about removal and retaining and things like that. Definitely for agriculture purposes, we need to retain this. And I think these things you need to take it forward. And any help needed across the country, I will be more than happy to do. Thank you very much.
Agencies. That makes a big advantage, right?
Yes.
Because the retention of the nutrients and then the follow-up actions like your short duration plantations and all that. So that I think has to be brought out to the notice of the government.
Yeah, I don't know whether it's the right platform to share, but since we have EU top officers and DST, DBT, so the program that we implemented, FP7 swings, and the technology deployed and developed, like constructed wetlands for sewage treatment. So it has been replicated on full-scale basis in the last 4 years at 25 locations in India. So that is, I think, one of the major achievements of the project swings. And similarly, we hope that we will also take forward these Pavitra technologies.
Yeah, one more question online, and then you take a call. One more question from audience.
Yeah, we have Mr. Anil Kumar, who has raised his hand. Mr. Anil Kumar, if you like, you can ask your question. Otherwise, there is a question from Mr. Asad Sahir from IIT Roper, and if you allow me, I can just read the question. It's about Aligarh. Thank you for the nice presentation. In the presenter's observation on Aligarh as a city, are there any possible technological solutions addressing issues related to the numerous open drains in the city where a lot of wastewater is visible? Is there a scope of behavior-based interventions going ahead? Thank you.
Yes, I can actually make some advertisement for tomorrow, because the short rotation plantation is using the open drain waters. It's more located to villages where you have like the open drain system, then you have a pond system, and we're using this water actually then to treat it in short rotation plantation. But yes, Aligarh, like many other Indian cities, have an open system, and only part of the wastewater is going to the treatment. Other one is going to like decentralized structures. And we actually focusing in Aligarh on technologies dealing with the centralized way, but also with the decentralized.
Yeah. One point regarding your septage treatment plant. Septage.
Yes, yes.
The solids that you are producing after the treatment, whether it is class A category biosolids or class B, because since you have to use it in the field, it must be class A. And the second point is relating to your rich water. You talked about retaining the nutrient in the SBR. SBR is famous for removal of the nutrients. So we are following our Indian guidelines, and SBR is suitable for that. Now, the question is relating to the standards, because the total nitrogen, total phosphorus, etc., that the NMCG is following today is about 10 milligram per liter, 1 milligram per liter phosphorus. So therefore, the standard need to be modified with respect to the sewage treatment plant. So the government agencies, therefore, is to take it into the court for changing the standard. Otherwise, how it can be adopted in the field? Okay.
Can I say something? For the rich water, I would like to say something, because I was involved in the European project before Pavitra. And we had exactly the same discussion. We said we modified an MBR in this case in order to reduce the treatment costs and having high phosphorus and high nitrate in the effluent. Then we use this water over a mixing station and a sensor station for irrigating crops, where the farmers reduce fertilizers because they got fertilizers with the wastewater. And then we had a discussion with the municipalities, and they got an extra permission by proving that they expanded the system. That means it was an MBR, or in this case an SBR, plus the land with the crops. And then they just said, okay, this is our system, and now we expand the system, and then they got the permission for this one. But you're right. Otherwise, it would be not legal in Europe, and it would be not legal in India. This is a really important point.
Okay. So thank you very much.
Thank you.
And congratulations. And now we will move to the last project of this session, which is Saraswati second. This one, yeah. So Dr. Marcus Starkel and Professor Mahand Gangre.
Sorry.
Okay. So we are discussing now about our progress and results of the project Saraswati. So just to okay. So to recall our objectives in our Saraswati 1 project, we identified that many of the decentralized treatment plants in India actually not working and that they have problems, operational, etc. problems. And therefore we concluded that we need better and newer technologies. And that's what we tried to achieve in Saraswati 2. So our overall objective was to identify best available as well as affordable technologies for decentralized wastewater treatment for India. We have our 5 thematic work packages. So the main is the piloting our candidates for best available technologies. And we have here 9 pilots in total across 4 dimensions for decentralized wastewater treatment, black water treatment, sludge treatment, and post-treatment. We're also monitoring those plants, optimizing them. We're doing experimental work, modeling, and finally a performance assessment. Besides, we also look at developing suitable automation and control systems, as this is a major problem for Indian decentralized wastewater treatment plant. There's no maintenance of those plants. There's no enforcement of regulations. And therefore, in reality, very soon after installation, they fail to function. And then we are looking at the overall sustainability of those plants and of course disseminating our results. So the expected impact, that's from our proposal. Of course, we will contribute to improved and efficient wastewater treatment across India. We will contribute to sustainable development goals. We will provide affordable and innovative solutions, and therefore contribute to business operations, and of course, we will support European and Indian SMEs in that field. So our partnership, we have 10 partners from Europe and 7 partners from India. We have our co-work package leadership, so each work package led by a European partner and an Indian partner. You can see here the names. I will not go into detail because of lack of time. And we were asked to discuss about transfer exchange of knowledge and scope of adoption and scale up. So I'm summarizing this here in those tables. So pilot 1, it was a USB deammonification plant. It has achieved TRL of 7. Here the technology has completely transferred from the European partner, University of Teutonia, to our Indian partner. There's no IPR protection foreseen. So all publications will be co-authored by European and Indian partners, and the knowledge will be made available to the public. So then this can be freely taken up, this knowledge, and replicated as needed. Technology 2 is a small-scale SPR. This was also indigenous Indian development, only by IITR. There was only an indirect involvement of European know-how because this technology has been inspired by CTEC. Some of you may know CTEC. CTEC is the market leader in India for large-scale SPR plants, and the company is SFC, which is based on an Austrian patent, and it is bought by the Indian SFC company. It has achieved so far TRL of 9. To achieve TRL 8, it needs to do further testing for wastewater that are more suitable for small-scale situations, which are expected to have higher BOD and higher flow variations. And for the scale-up, this will depend largely on the availability of funding from the side of the Indian government. Some funding schemes are already in place and future funding schemes are expected. And RIT, of course, they plan to patent certain parts of this technology, and then they will give a license to an Indian company, which they will select based on their own network of companies. And then this company having this license can participate in tenders for the Indian market to replicate this technology. Then our third is BioCube. This has achieved in India so far TRL 8 to 9. It has achieved TRL 9 out of India with more than 6,000 installations. In India, it has so far around 65 installations. However, they're mainly in the private sector. And for the public market, there's a major barrier, which is a tendering procedure. So in most of the tenders where our BioCube is participating, the tenders are not suitable for this type of technology because either these tenders are only focusing on the capex cost, which is the so-called L1 principle, and BioCube being a technology having major advantages for low operation maintenance costs. This cannot be considered in this type of tendering system. So if you want to replicate this more in India, the Indian tendering system would need to be adjusted. Otherwise, this would have a very high potential because it has the major advantage that it does not need a local operator and it can be fully monitored remotely. Then RBC and disinfection, this is still in progress, so here we'll not discuss more. For technology 5, anaerobic digester for the bioreactor combination has achieved QL of 6. It was transferred from TU Delft and University of Antwerp to India. It can be used in a decentralized setting for recovering resources. And also here, a further testing is needed to achieve QL of 7 to 8. For pilot 6, anaerobic digester electrically conductive biofilter, this technology was transferred to Spain. A patent is held by the company MedFilter in Spain. And here we will discuss tomorrow in the pitching day about the potential of this technology. Technology 7 is Cambi, is a thermal hydrolysis plant. Although this has achieved QL9 outside India. In India, it is still QL7 so far. Further investments are needed to achieve QL9. And also this, because there are major institutional barriers to replicate this technology in India. We will discuss also this more tomorrow at the pitching day. And finally, technology 8, ultrasonic sludge disintegration, has achieved QL of 7. It's also very promising for Indian conditions. And it was developed indigenously by Indian companies managing innovation together with IIT Kharagpur. And our pilot 10 ion exchange membrane bioreactor has achieved a QL of 6. It was based on a patent from 2001. It has been modified in our project by Ben Gurion University in Israel and IITM. Certain parts are expected that can be patented or IPR can be protected. And then here there's a scope, of course, for replication. And now we'll go into detail of the pilots, and President Rector will take over.
Dr. Marcus, and good afternoon to all of you. So the pilot one under Saraswati 2.0 project was on piloting USB reactor, followed by Anamox process. And this pilot is installed at IIT Bhubaneswar. And more than 6 months performance of this reactor has been monitored. And you can see the performance input with the input BOD of less than 280 milligram per liter. The final treated water has a BOD of less than 20 milligram per liter, COD less than 30 milligram per liter. Even because of the involvement of Anamox process, the ammonia is brought down to below 7 milligram per liter, and total nitrogen still it is slightly crossing the NGT limit of 10. But over the period of time, the performance get matured, and our partner is evaluating the optimum loading rate. So with that, we will come out with the total nitrogen loading also below 10 milligram per liter, and total phosphorus also between 1 to 2 milligram per liter, which need to be brought down to below 1 milligram per liter. So overall, this pilot is successful in treating sewage and generating methane at the same time, and treated water can be reused for non-potable purposes. The next pilot is pilot 2 on demonstrating the 100 KLD sequencing batch reactor SBR. The purpose was to necessarily concentrate on the selector portion of the SBR, which provides anoxic condition, so as to optimize the nitrogen removal simultaneously along with the organic matter removal from the SBR. The research question was large quantity wastewater treatment SBR plants are existing in India. However, the small plant below 1 MLD are very low, and we do not have really operational experience how denitrification occurs in such a small scale SBR. So with this intent, we installed 100 KLD SBR plant at by IIT Roorkee. And it demonstrated reasonably successful performance with the COD about 21 milligram per liter, BOD less than 10 milligram per liter, TSS less than 10 milligram per liter. Total nitrogen here in this case is below 5 milligram per liter, and even total phosphorus is below 1 milligram per liter, satisfying all the requirements that are given by the NGT. So that way, this plant the performance has been optimized by our partner. The third pilot is BioCube. We have two installations, one for treatment of the pharmaceutical wastewater from laboratory wastewater, and then the other with the domestic wastewater. Domestic wastewater, this BioCube plant gave satisfactory performance, meeting the effluent norms. But when it comes to the pathology laboratory, then our partner, MNIT Jaipur, could find out some of the ARG present in that wastewater, and they are still researching into it to find out the ways and means to make this water also safe. Some post-treatment will be required after BioCube to make this wastewater safe for downstream reuse. The pilot 4 and pilot 9 were combined together. In the initial proposal, they were supposed to be installed at two different places, one comprising of RBC, and the 9 is electrochlorinator based system. So both are installed in the Mumbai itself at the BMC site. The purpose of this technology is optimizing performance of RBC with the modifications in design and operation to facilitate producing reusable quality treated water. The research question was to implement affordable technology for sewage treatment with higher treatment efficiency and produce safe quality treated water to facilitate reuse. And we can see the performance of this plant. It is producing effluent with pH near neutral, BOD around 30 milligram per liter, which is typical standard at present. COD less than 90 milligram per liter. TSS is also less than 25 milligram per liter. Ammonia and total nitrogen is meeting the NGT norms even less than 10 milligram per liter. But we still need to optimize on the performance of electrochlorinator, which is offering downstream treatment to the effluent generated from RBC. And those efforts are on. Some hurdles were there because of non-availability of the sewage. That problem has been fixed by our partner IIM Mumbai, and they are into operating this plant again for studying further downstream disinfection process. The pilot 5 was on installation of anaerobic digestion coupled with photoheterotrophic bioreactor. Here, the purpose of this technology is to provide cost-effective wastewater treatment solution to facilitate resources recovery in the form of biomass. Here, we are targeting to recover purple non-sulfur bacteria in a reservoir pond kind of reactor. So, the reservoir pond present an alternative.
Gangrekar, you want to change the slide, sir? You want to change the slide? Professor Gangrekar. Yeah, thank you.
Thank you. So you can see in the photograph the small reservoir pond of 1 meter cube, which is put under operation, and you can see the purple color of the wastewater. So high rate anaerobic digester with 3.5 hours of retention time just acidifies the organic matter, and this acidified organic matter with the VFA content in it is fed to the PNSB containing reservoir pond. And there we could get, we operated with the batch mode. Also, we operated with the continuous mode. Of course, the performance is slightly inferior in the continuous mode of operation, but still appreciable performance of more than nearly 70% COD removal efficiency, and also about 2/3 removal of nitrogen and phosphorus. So this experiment is still on. Now we are into the process of operating, means the plant is under construction and will be finished. So we will operate 100 cubic meter per day plant. But right now, what is in operation is a small plant of 1 meter cube. However, the anaerobic digester is full capacity, 100 cubic meter capacity anaerobic digester, high rate anaerobic digester is under operation. The pilot 6 is on again anaerobic digestion coupled with electrically conductive biofilter. So here in the previous Saraswati project, the USB reactor, what we have installed. So that is being utilized, and the USB effluent is post-treated in the electrically conductive biofilter. The purpose of this technology demonstration is to produce water which is safe for reuse. And the research question is to check the technical, economical, and environmental assessment for adaptation of this technology in the Indian context. Our European partner has demonstrated this technology for industrial wastewater treatment. However, this large-scale experience is not available for domestic wastewater treatment, and that is what we piloted, and we evaluated performance for more than 15 months now, and you can see the performance parameter, which are very much under control, meeting all parameters for as per the NGT recommendation. Let it be COD, let it be TSS, total nitrogen, total phosphorus, as well as MPN. So after electrically conductive biofilter, we do have electrochlorinator. So we give NaCl, 8 gram per liter NaCl concentration, it generates chlorine, and then those have chlorine dose and OCl dose that we add to the effluent. And that way, the MPN also is brought under control. So this plant is also successfully producing treated water, which is safe to be reused for any non-potable purpose. The next pilot is the Kambi thermal hydrolysis pilot. The lead partner is IIT Roorkee. The purpose of technology is to evaluate performance of thermal hydrolysis for a full scale. This process is used in the full scale in the developed nations. However, we do not have Indian experience, and this is what the target was. The research question was thermal hydrolysis process, which shows means how much methane incrementation that it shows that we evaluated. And in summary, for SBR sludge, sequencing batch reactor sludge, the 3.8 times increase in yield of methane is observed, whereas for conventional activated sludge, when it is treated with the thermal hydrolysis, it resulted in nearly 2.4 times increment in the sludge. Apart from that, it also helps in reducing the pathogens content in the sludge, classifying the sludge, as Professor Mujumdar has asked previously, in the class A category sludge. So that way, this technology has application, and we'll cover more detail in each session tomorrow. The next pilot was again on the treatment of the sludge using ultrasonication treatment. The purpose of technology is to provide pretreatment to the aerobic sludge generated in the sewage treatment plant to increase the methane yield. The technology provider here is Indian partner, Indian partner who has developed managing innovation, who has developed this technology. And the research question was emphasizing on upscaling towards direct hygienization of the sewage sludge, and that too at the low energy spending. However, our experience is when we are putting low time sonication time, less than 15 minutes, then this is an energy win process, the net methane yield that it increments. So that add on, but however, if we extend the sonication time beyond 15 minutes, then the energy upfront that it consumes for the pretreatment is much more than the net increment in the methane yield that we have by this pretreatment. Also, the added advantage is a log reduction in the pathogens content of the sludge. So you can see, I mean, about 2/3 reduction in the pathogen is happening there, but still it is not leading to the complete reduction, and the downstream further treatment may be required to classify the sludge under class A category for further downstream uses for field scale application. Then the last pilot is nitrate removal using ion exchange membrane bioreactor. The technology provider is Ben Gurion University, Israel, and IIT Madras as an Indian partner in joint collaboration. This technology was actually developed for removal of nitrate from the fresh water, and we are trying to implement it for nitrate removal from the secondary treated effluent. And hence some advancement, some modifications in the membrane and the reactor arrangement than what they had patented the technology in 2001 were required. And our partner involved successfully carried out the performance evaluation for more than a month now. And nitrate removal, more than 90% was achieved from the secondary treated effluent using this Donan exchange principle that is involved here. So, and then the water which is concentrated with nitrate is using fixed film reactor, denitrification reactor. This nitrogen removal is happening, and then this way the water is being recycled for further Donan exchange process. Presence of sulfate also had showed minimum effect on the denitrification. And on this pilot, we are also working on the PLC-based control systems, microprocessor-based control systems at the Nesapakapam sewage treatment plant, where this pilot is being installed. And the operational cost of this plant is expected to be less than 17 rupees per meter cube of the water that we treat. And here, the outlet values will convince you that nitrate 2 milligram per liter, sulfate also about 2/3 reduction, phosphate also 2/3 reduction. Chloride, of course, we are using chloride as ion for donor exchange. So some increment in chloride values are happening while the wastewater is getting treated using this technology. So again, I will hand it over to Dr. Marcus for continuing presentation.
As mentioned, another part of our project deals with automation control. So we analyzed the control strategies applied in some of our pilots in Saraswati, and then our partner TU Delft was experimenting with MPC systems and model predictive control systems, which can help to automate our operation of wastewater plants in India. This is done in pilot 5 and part in pilot 10. And this match is very important for India because if there's an absence of skilled laborers, which is also a major barrier in India, so this can help to overcome this. And as a result of this work package, recommendations will be elaborated how operational automation of decentralized wastewater treatment plants can be improved across India. So final work package 5 on sustainability in work package 6. Here we did a life cycle analysis. You can see the picture. The LCA results are all our pilots. We also did life cycle costing, but those results are not yet available. We also looked at other sustainability aspects, social, etc., as required. We did evaluation of health benefits of wastewater treatment using cost of illness methods. And we looked at barriers and drivers, some of them mentioned earlier. We also published a paper on these barriers where you can read more details. And as one of our major dissemination events, we participated, or we had a Saraswati session at the IFAD Mumbai conference, which is the largest trade fair in India for wastewater technologies, where our SME partners, Cambi and Waterneer, are showcased their pro technologies. So last but not least, what happens to our pilots after project completion? Most of them will continue to be operated. Only pilot 2 was meant as a temporary installation and will not be used further after project completion. But other pilots, they expected will be continued after our project ends. Thank you.
Almost. Any questions?
Still not? Yeah. No, yes. So is there any question in the room? Tanya.
Very much. Is it on? Okay. Thank you very much. A nice presentation. The question would be more from a general policy point of view. I'm not a scientist, and it seems that there's for the 10 different technologies that you have presented, there's still a lot of research questions. So would it be fair to say that you are not yet there for the market uptake, or because you haven't put much emphasis on that in that presentation today? You have still many research questions, and after the project, there will be still a lot of testing that will be done. Would that be fair, or is it?
It's different for technologies. I showed this table earlier. So like BioCube, our pilot 3, they already have 65 installations in India. So they are already active in India. Other technologies have reached tier L of 6, 7 to 8. So they would need further investment to reach tier L9 to be really cost competitive as a large scale application. And for Cambi, it's mentioned it's a company that has been installed worldwide, but in India, there are major institutional barriers, which it's not a matter of the technology readiness, but on institutional barriers in India that hinders the adoption or application of these technologies in India. So it's different for each technology.
Biofilter is also ready.
Yeah.
Overall, you seem to have still a lot of research.
3 to 4 technologies are ready for installation elsewhere. Other need further investigation to make them ready from TRL 8 to TRL 8.
Chanakya here. The country as such is now moving out of anaerobic digesters and then going into predominantly SBR and managing its old ASPs. You are projecting a very strong confidence using anaerobic reactors. What gives that advantage other than the nutrients that we capture? Why do you see that they will make a resurgence into the future? And what's technical strengths which we can showcase into the future?
So thank you, Professor Chanakya. Actually, utilizing high-rate anaerobic reactor, even if it gives me 2/3 organic matter removal efficiency, at the end, downstream process, when I have to post-treat it, there is a net saving of the energy that I have to spend on SBR. So that is one advantage. Second advantage is in the process methane that I recover, that can be used on site as an energy source. So that definitely indeed gives me advantage, and protecting the nutrients which are present in the effluent, as what earlier presenters have also showed, that if we protect the nutrients, then the water can be better quality water to be used as irrigation with nominal disinfection as per need. So, and I have successful experience of over 20 years for operating USB reactors, and I'm confident to operate the reactor to give more than 80% BOD removal efficiency and about 70% COD removal efficiency if we properly design it. So that's why I propose.
My question was that I agree with you technically, but most of the psyche of all our wastewater treatment system operators, I'm not talking about people who are in this room, but people who are operating, for some reason have a tendency to go shift towards
aggressive marketing that the CITEC is doing.
So that's why you need to, how do you propose? Perhaps one thing, if you give me 1 minute. One thing is that the Satat program has now made it commercially extremely viable. And if you add the nutrients part, which you add, that could be projected into future as something that the direction which both the country as well as the world should go in.
Thank you, Professor, for your suggestion.
We will go online first, and then a question in the room. So,
yeah, can I come in? Yeah.
Yes, come.
Yeah. Thank you, Professor Starkal, Professor Gangrekar. Very nice presentation. And I think as we discussed, as of now, we need to really follow all the NGT standards as of now, legally. In that context, I think some of them probably the treatment plants output were not matching. Am I correct, Professor Gangrekar?
Yes, yes, sir.
So as though we wish to retain our nutrients, we wish to do all that, like the discussion which happened earlier also and even now, unless we change the policy, we cannot do that, as of now, unless somebody goes to our court or whatever it is, or change the policy. All of us are legally bound to follow the NGT standards.
Yes, sir.
Any quick comment? Yeah.
Actually, we are debating that whether the total nitrogen of 10 and phosphorus of 1, whether it is really needed for disposal into irrigation. So, but that's a policy standard.
No, on a personal note, I also agree with you that we need to retain it, but the legal framework as of now is bound. Yes. Maybe we need to address, as Professor Chanakya said. And I think one more thing quickly, commenting on your observations of your team, especially Professor Starkal was putting about. As of now, we cannot change the tendering process. If it is L1, that is L1. That's all it is. The other way around to look at, can you make your technology, your group's technology, which is attractive as an overall, the package, where the people will buy the technology along with the package? We cannot say deviate from L1.
Sir, but Dr. Marcus will address it in detail, but instead of only capital investment L1, if we consider life cycle costing of the technology, so that will be much more relevant, I feel so.
Yeah, exactly. That's what I said. We are not going to have a discussion, Professor Starkal, maybe tomorrow sometime. The point is we cannot say change the tendering process. It will never happen. Thank you.
Yeah, if I may enter here, I think that's also a challenge for European Commission, European Union to try to discuss with Indian counterparts. Like in Europe, we went back from the L1 principle a long time back. In Europe, we have the best quality criteria, and best quality is not only cost, it's all the other things. And maybe if Europe could be proactively let's say, address India in that regard and convey to them the benefits of such an approach. And this ultimately might help to change the tendering process. This would then help very much also European technologies to succeed in the Indian market.
Yeah, anyway, it's a point of discussion for tomorrow, not today. The whole package should be seen, and even the tendering process, each is the individual tendering here. Any water boards, nobody can probably guide them what to tender, what not to do. Thank you.
And we come back to the room.
One point is, Cambi is in the market in India. Actually, they said that if you have a thermal treatment of the sludge, then the production of the methane will be more in the digester. Now, your work, your study with respect to Cambi, what you will be supplementing to their product, which will be advantageous?
No, this I can answer in absolute detail because I had a Zoom call with Cambi just a few days back. Cambi is not yet in the Indian market. They participated at the tender in Mumbai, but as far as I got information a few days back, the contract has not yet been awarded. And when our project started, Cambi had not yet had installation in India. And their problem was that India has mainly SBRs. I mentioned earlier CTEC. So CTEC is the market leader in India for SBRs in larger scale plants. And the sludge from SBR plants is different from the sludge that Cambi installations have outside India. And to see if Cambi system is suitable also for this SBR sludge, this was studied in the pilot 7 of Saraswati in Rishikesh by IIT Roorkee, and results have shown that Cambi in fact can also handle this sludge, and results are very positive. But as also I will mention tomorrow, that Cambi can enter the Indian market again, there's a major institutional barriers, which we will discuss tomorrow in more detail, and unless these barriers are not overcome, it will be difficult for Cambi to enter the market.
A couple of months ago, Calcutta Metropolitan Development Authority organized a program where Cambi came, and they suggested that that could be a centralized Cambi thermal treatment plant where the sludge would be brought from different sewage treatment plant, and then it would be put into the digester. So therefore, we found that Cambi has come in Indian market at that time.
But have they got the contract awarded? Did the contract has the contract yet been awarded?
No, not yet. Not yet contract. But the issue is that they came to the market, they presented to the development authority that we can give you the solution to this sludge problem, and ultimately we'll get biogas as well as your solids should be class A as per EPA US.
His partner.
He was also at IFAT Mumbai when we had our Saraswati session there. Dr. Mitra was there, participated in our Saraswati session.
Okay. Yeah, thank you very much. I think if there is no burning question in the room, no. So we can close the session here, and we have now a lunch at this program. So enjoy your lunch and see you this afternoon.
So the lunch is just upstairs. I mean, if we just walk up to the foyer, the first level, that's where lunch is being.
Start ahead of time, Just over.
Before this.
Yeah. So they are encouraged to stay. So before we start the session, an announcement. So we have an extra tea coffee session that is not in the agenda, but it's actually, and will happen at 3:30, if you are on time with, with your presentations. Okay, good. So we can start this afternoon session with the last 3 presentations from the project. Here with me is Dr. Madamba. You want to say a couple of, we call immediately the project?
Yeah, we can.
Actually, and for the first one, we have a mixed mode because one of the speakers, Dr. Mudgal, is here with us, and the other, Philip Davis, is connected online. Philip, can you hear us?
Yes. Yeah, I can hear you.
Yeah,
Thank you.
I can hear you.
Good
Thank you.
morning.
Yeah.
Good afternoon.
Okay, so I don't know which we go. Yeah. Good morning. Indeed. Yeah.
Times we may invite the first India Water.
Yep.
Afternoon. We have some pointer or something that will be helpful if we, yeah, thank you. Thank you very much, and good afternoon once again. Hi, Philip.
Hello. Yeah, I'm here. Yeah.
So I am here to speak on behalf of India's tour project. These have been our elaborative objectives. So our main objective was to lower down the specific energy consumption, which has been a main difficulty in all desalination processes. Specific energy consumption, and other is recovery ratio. So we succeed in getting a specific energy consumption as low as less than 1.5 kilowatt hour per 1,000 liter or per cubic meter of treated water, and recovery up to 75 to 80%. And the bottom line of our objectives have been to suggest some zero liquid discharge system with some value addition and some societal impacts that should be directly connected for societal impact and not constrained to boundaries of a laboratory, to work on controlled environments only. So these have been our elaborative objectives. So I'll try to narrate one by one in upcoming slides. Yeah, I think we can skip this. These are our partners from Europe and India. Israel has been our partner out of Europe. So the main theme of the project is that whatever category of water it is, either it is domestic wastewater or industrial or brackish groundwater, we are not dealing with seawater, but brackish groundwater along the coastline of the sea, where it mixes with some inland water bodies and comes to a salinity to say up to 5,000 to 10,000 TDS. So routed through some glycophyte plantation, some wetland construction thing, then do some physical processes, and we made unique batch ROFO module, which work on a pressure exchanger concept that lower down the specific energy consumption. And then we get about 75 to 80% recovery at a very low specific energy consumption, and the reject which comes at a volume, say 25% of the total input. We grow some helophytic crop called Salicornia. The sample I have kept there. So we got all the guidance from our Israeli partners on that. This is very famous in Israel. And I hope that my European colleagues, they will be knowing what Salicornia is. This is very famous in Europe, I heard. So we divided in work packages. all partners were given different roles to play. This is the one slide outcome, if I say. We created one center of excellence in water treatment. This is like water clinic. So whatever category of sample comes, we diagnose it and we can suggest what are the remedial options. We will suggest shops also, like a doctor suggests medical stores. We can suggest vendors as well. We created list of vendors who will do what. For doing so, we installed 2 batch ROFO units, one at my campus, Pandit Dindayal Energy University, Gandhinagar, Gujarat, and other one for field experiments at a very remote place, very near to coastline. You can see that map near Saurashtra. The aerial distance of this place where arrow marks is about 2 kilometers from the sea line. So we installed one system there. With reject, we grow salicornia.
Would you like me to describe this one?
The idea came. Yeah, yes, please.
Okay, so this system is the version of the system that we built at the University of Birmingham. This is about the high recovery RO system. And as Anurag was saying, it's designed to recover 80% or more water. In fact, we can go up to 95%. And at the university, we built versions of the system that are rated at 20 bar, which is sufficient for the brackish groundwater. And even we built systems going up to 120 bar, which can do the very high recovery. Then we tested several types of membranes in it. So working with our partners Aquaporin from Denmark, who are also in the project, they have some very high permeability membranes. So to go with the batch RO system, the high permeability membranes, we can get very low specific energy consumptions. And so the Indian team overcome huge challenges actually to install and operate these systems in remote village locations. You know, everything will be much more challenging when you have all these long distances and rural places, but everything's working now in a very similar way to what it is in Birmingham. Next slide. Please, Anurag, you this one.
Yeah, okay. Thank you, Philip. So to make a close monitoring, our partner Siri Pilani, they developed low-cost sensors, real-time sensors. So we can see the parameters online on a mobile or laptop from a remote place. Whatever is the inlet flow rate, inlet quality, outlet quality, we can monitor those. So these are flow sensors, TDS, whatever pressure, all the monitors we can monitor from a remote place. And when villagers run it, we can see, we can realize that the system is working with the desirable parameters or not, and we can communicate with them what corrective measures need to be taken. So a lot of scope, it can easily be seen that integrated this thing, batch ROFO technology is useful because of its low specific energy consumption and high recovery ratio. In normal continuous RO systems, recovery ratio has been a constraint. Then with FO module, we can again rope in domestic wastewater, which is not potable, but has low salinity, even if it is not potable, even this is not potable. So with a natural pressure gradient developed in the forward osmosis process, and some water flows down towards high salinity water. So we create 2 streams, one with reject of HRO and other with domestic wastewater. And we saw that this further increases the overall recovery to about 80%. This is the technical part. So this is how, Philip, would you like to say
Sure.
on this? Or
Yeah, sure. This is sort of going into the details of how the batch reverse osmosis system works. So when you see these machines, you see an upper module, which is the RO module, and a lower module, which is called a pressure exchanger. So externally, both these units look very similar, but inside they're different. So the upper unit contains the membrane and the bottom unit contains the piston. So essentially, the working principle of this system is one which minimizes the pressure that you need to drive the system. So what you see on the right is a graph of peak pressure and the pressure that we actually apply. So in the conventional reverse osmosis system, the situation is the situation of the graph right over to the right, and then you need the maximum pressure all the time. Whereas in the batch reverse osmosis system, you use an average pressure that's very much less. So the average pressure could be half or even less than half the pressure used in the conventional system. And that that's what gives the energy saving in the system. So the system works through two phases: the pressurization phase, which is the longer phase, and the purge and refill phase, which is the phase when the brine is purged out of the system, and the phases just repeat alternately.
So we use proximity sensors to sense when this piston has to stop, when this has to come back. All proximity sensors have been installed, and there is nothing manual we need to do. This is switch on, switch off kind of machine, and villagers are running this. We gave them training for 4 or 5 days, and they are running this without any concerns. And this is what Philip was elaborating, that for a continuous RO, we need to maintain a consistent pressure, which we can see on the right plot. But in batch RO, this pressure exchanger stores the energy. This works as an energy reservoir and releases the energy as per the requirement. And that cut down the specific energy consumption. So this system delivers 800 liters per hour out of 1,000 feet. 800 liters per hour permeate and 200 liters reject with all salts accumulated in it. This is the system which we installed in what I was saying, that we created one center of excellence of water treatment at PDEU. This is PDEU unit, what you are saying, enabled with all sensors. We are trying to route hostile wastewater through a wetland construction and phyto treatment system. So we are doing this in separation. We have not yet integrated it, but soon we are planning for that. So this is the range of parameter in Lodwa, where our village unit we have installed. The salinity varies from about 1,500 to 4,500, depending on the season. When monsoon is over, then TDS is a bit low, and by the time next monsoon comes, the TDS will go high. So we have checked this machine performance in all the conditions, and this is running good. When TDS increases, the only thing which we observe that pressure requirement increases if we are stick to 75% recovery. And this is basically a trade-off. We can even get more recovery, but we need to put more energy in terms of creating pressure.
Yeah.
So what we learned that this is pressure actually. This is not electricity which runs. This is the pressure. If you pressurize it with sufficient pressure to pass the water through the membrane, the system works. And magic lies in doing all peripheral arrangements and designs so beautifully so that we can scale it up, scale it down. This should be rugged, should be user-friendly so that even at a rural place for what we created this should work. In the next step, please, Philip.
So I just wanted to add that on the about the specific energy consumption, which is the graph at the middle at the bottom. This was one of the key objectives of the project, to get a specific energy consumption of less than 0.4 kilowatt hours per cubic meter. So this is very much less than most desalination systems. Normally there will be one, or sometimes, you know, much greater than one, even 5 kilowatt hours per cubic meter. You can find systems like that. So a system of less than half or less than 1 kilowatt hour per cubic meter, I would say, is quite unusual. And we've got very similar. Now we've got very comparable results between the systems at the University of Birmingham and those constructed in Gujarat. We've published several publications together, you know, analyzing all these results and showing how their energy consumption is, the different components of energy consumption, how it's determined, how to optimize it, how to minimize it is well understood now. Thank you.
Thank you, Philip. In continuation of that, the lower one and rightward graph, it shows how TDS varies in pressurized mode. This starts with low TDS, then fluctuate in between, then go to high TDS, and then go upward by the time forward stroke is completed. And we receive permeate in the forward stroke only. So we saw that even if we change the TDS or change the flow rate, this trend remained consistent. There's something called reject management. So we have Ben Gurion University with us, our Israeli partner Moshe Sagi, very senior scientist. So this is Salicornia actually, and this grows in salt. This is salt-loving plant. This will not grow in normal water. So we saw that with the reject, we can grow it. And surprisingly, we noticed that the geographical conditions and the weather along the coastline of Gujarat, which is 1,800 kilometer long, 1,800 kilometer, and towards inland, 15 to 20 kilometer, salinity is a big concern. Farmers are not able to grow the traditional crops, even when they grow it, a peanut and a cotton, the yield is very less because of salinity. So we observed that natural saline conditions are favoring one of the Israeli ecotype in Gujarat. So we are trying to replicate the Israel model at all along coastline of the Gujarat, and we are exploring market. So we couriered about 100 samples to big chefs of India to test it and to get their feedback. I brought some samples here as well. This is how we did it. So this is a Swaminarayan Trust school, Neelkant Varni school, who gave us land in the village. And with all rituals, we installed the plants. So at the left-hand side, you see the machine, and on the right-hand side, Salicornia field to do the reject management. These tanks are lying outside. Different tanks are for different purposes. The achievement, these are more or less same, which I have narrated in my talk. So we are able to get good quality of, I will not say best, but this is as comparable as Bisleri. We drink Bisleri for 15-20 rupees for 1 liter. We are giving this water free of cost to about 7,000 villagers. All school kids, school staff, they are drinking it for free. And to make the system sustainable, we signed an MOU. So there are 3 parties. One is the village governing body, which we call Gram Panchayat. Other is the school trust. And third one is the India H2O project, the machine itself. So to make the system sustainable, we suggested that you create 3 parts of whatever revenue generates. One will go to the operator, one will go to the trust, and third one will go to the plant maintenance. So that it will not happen after the age of project. It will not go scrap. This will remain sustainable. So we are getting water at a cost less than 0.5 paisa per liter. This is how they are marketing it. We have registered initially as a micro enterprise within the name of that school only, Neelkant Varni. We regularly do testing of our permeate water through recognized laboratories. These are the salicornia samples you see at the bottom. And in the middle one, you see the indigenous design created by the villagers themselves to sell those dispensers. One dispenser is of 20 liter, and they are able to market 50 dispensers 15 days back. And now 2 days back only, they have purchased another lot of 60 dispensers. So this is the rate how this is progressing, because it needs time for trust building. We started with free sample we provided free samples, and then gradually they keep receiving the orders, and now they are able to deal with 100 dispensers every day. So we are providing one dispenser for 15 rupees, 20 liter water for 15 rupees. So 100 dispensers means 1,500 and 45,000 in 1 month. This is public engagement. I need not to, we have organized 3 international conferences. Next one is coming in on 1st and 2nd March. So I'll send everyone an official invite. If I have saved few minutes, click on any of them just to get a feel. Much of this will be in Gujarati language, local.
સૂત્રાપાડા તાલુકાના લોઢવા ગામે નીલકંઠ વિદ્યામંદિર સ્કૂલ ખાતે મૂકવામાં આવેલ વોટર પ્લાન્ટ
No, anyone.
ઉઠવા ગામે નીલકંઠ વિદ્યા મંદિર સ્કૂલ ખાતે વિશ્વના સૌ પ્રથમવાર ભારતમાં H2O પાણી પ્રોજેક્ટ ખુલ્લો મૂકવામાં આવ્યો હતો. ભારતનું આ પ્રોજેક્ટ છે જે 1 કલાકમાં જ્યારે બાકીનું 200 લીટર પાણી જે વેસ્ટ થાય છે તે વેસ્ટ પાણીમાંથી ઇઝરાયલમાં થતી ખેતીનો પ્રયોગ ગુજરાતમાં થઈ શકે તેથી આ પ્રોજેક્ટની ટ્રાયલ શરૂ કરવામાં આવ્યું છે. તો સમગ્ર ભારત દેશમાં આ વનસ્પતિની ખેતી થાય અને દેશના ખેતી કરતા ખેડૂતોને તેનો ખૂબ જ મોટો ફાયદો થઈ શકે છે.
Thank you.
ભારત સરકાર અને યુરોપ સરકાર સાથે મળી
he is a villager who is being interviewed, and once this news reached to media, at least all Gujarati TV channels, they went there, they covered it, they did the coverage, took interviews of the villagers. What is this? How you are treating water? Water is such a big problem there. And they are looking at salicornia and with high spirits. They are looking at it that this may be something which can increase which can uplift their livelihoods, because they have no options. They are migrating from there actually. And another big issue is that limestone industries, they are digging from the ground, and that further increases the seepage towards inland from the sea, and that gradually increasing salinity day by day. So this is a win-win situation. With salicornia, it is very likely that salinity will go down gradually, and they are very happy with this. They say that our children should not face the problems we are facing. When we were kids, salinity was not such a huge problem, but gradually this is increasing. So this is a big thing. This is a big mission, and this cannot be achieved overnight. Awareness, trust, sentiments, psychology, a lot of things come which is beyond technology. But we are on it. Thank you.
Thank you, Dr. Arvind. Now it's open. If there are some queries, some questions.
Okay, nice presentation. So just one kind of clarification, how you can replicate this for different sites, and will it depend on the initial TDS level, whether the technology will have to be optimized or not?
Yeah, thank you very much, sir. Thank you for that question. I love to answer that. Though Philip is expert of it. But what the pressure exchanger is, the volume of pressure exchanger, pi d square by 4 into L, that is the size what we are supplying in one forward stroke. So this is matter of diameter and length of the cylinder only. We can upscale it and downscale it. And in one of my BTech students, he is so much enthusiastic that we are working now on a household tabletop model, which will create some 100 liters per hour. So we are trying that also. So maybe in coming times, this will go to households as well, which can replace continuous RO with batch RO. Would you like to add something, Philip?
Yeah, so to answer the question a slightly different way about the TDS level that it can handle. So in the laboratory with our system in Birmingham, we've done experiments with up to 5,000 part per million feed at 80% recovery. If we want higher feed salinity or higher recoveries, then the 25 bar system would probably not be enough. So then we could have like a system rated at say 50 bar or 80 bar. Generally speaking, that's perfectly possible. It's just that it would add some cost to the system.
Yeah, thank you, Philip. I missed that part of the question. Thank you.
Yeah, thank you. Continuing on that, do you see any issue of membrane fouling? Because your water quality will have a lot of organic material. I'll just ask the 2-3 questions. You can answer all of them. Then we are continuously adding salt in Salicornia. So someday the salt saturation in soil will become so high that you may not even be able to grow Salicornia. Is there some kind of a salinity removal idea that you will have? Of course, you're planning to market Salicornia, but I don't know, see whether it will be a market. And the last one, if you go to Kutch, I think it will be a really great breakthrough if it works in Kutch, because there's so much of problem with fresh water there.
Thank you very much, sir. So fouling, we observed fouling first in PDPU plant because we started with that. And like doctor sense with fever that there is some infection. So the sense comes from pressure requirement. So all of a sudden, when fouling occurred, we observed that pressure at which system was working well was in the range of 10 to 12 bar, and it reached up to 20 bar all of a sudden. That was an indicator that there is fouling. Then we did acid cleaning, SCL, in the supervision of our IHE Delft partner. They are good in that. And then again, pressure come down to normal range, 10 to 12 bar. So acid cleaning is required as and when pressure is we sense it with the pressure. When pressure requirement goes up, we came to know that this needs cleaning now. The second question was about
the salt build up in the soil.
Salt saturation. Yeah, I encounter this question every time. This is very obvious question because where salt will go. So I save my face saying usually that we are doing this where other options are not available. So even if salt accumulates, normally we need not to bother perhaps because there is no other option otherwise also. But Moshe told us that this plant takes 10 to 20% salt only out of the what irrigation we provide. With the salt content, the irrigation we provide, this the plant uptake 10 to 20% only, and rest of that will keep accumulating in the salt, and gradually this will go in the deeper reservoirs. But this is true. If we could find some mechanism that soil could be rewashed or something, that will be great, really.
There's a practice of irrigation holiday in saline crops where one season you don't grow the saline-based crops, but you use rain-fed. So that option, I don't know. I don't have an experience, so I asked this option.
Karnal, yes. So I got one email 2 days back only, Blue Aqua Life. So they do all the work in this area, how to cultivate in saline conditions along the sea line, and they are interested in collaborating with us. So maybe they will also be suggesting something. I'll catch up with Karnal. And the third question was regarding, I'm sorry,
marketing this
with
and
my
the
short
Kutch area.
Kutch area, yes. So we will definitely, sir, we will definitely go and look at there. I have several farmers who came to me knowing this, that, sir, I have huge land. If you could do, I'll give you my land. If you could grow it and if I could get something out of it. So this is the situation, sir.
Anyone from online? Somebody.
Yeah, can I come in?
Yeah,
Chairman? Yeah, thank you. Yeah, thank you. Thanks for the nice presentation, Professor Mudgal and Professor Davis. My question is slightly different. In fact, as a part of CPHUO manual, we are looking at the possibility of a dual water supply system in coastal places where we bring down the salinity to acceptable level. So it varies anywhere from 500 to 2200 or something like that. By doing this, for example, just acceptable around 2000 plus, are we going to save energy, and is it a possibility using your technology? In fact, that saves a lot of this thing for our non-potable water supply in coastal areas, dual water supply. Thank you.
Can I
Thank
answer
you,
it?
sir.
Can I answer
Yeah,
it?
okay.
So it's
Yes,
about
please.
reducing the salinity, but not producing actual pure water. So it's a nanofiltration can be an option for this. So the nanofiltration membranes, they have some lower, more partial rejection. So they will produce a permeate that could be more saline, and there are many types of nanofiltration membrane available. So we have started to test nanofiltration membranes in our systems. The only thing is that the output will be not necessarily having the same balance of ions. This nanofiltration membrane would preferentially let through the monovalent ions. So that depends on what you wish to achieve with the permeate quality.
Okay, thank you. The whole idea is whether it is, the cost will come down, and it could be a source of water supply for the non-potable. Yeah, that's the question.
You're right.
Thank
yeah,
you.
no, definitely. Yeah, no, that's true. Yeah, the pressure requirement will be less. Yeah, no, absolutely, absolutely. Yeah.
Thank you.
Just for curiosity, maybe you are aware of that closed circuit RO from FilmTech, CCRO.
FilmTech, yes. We are
How
using
it is
the same
different
membrane.
than the batch RO? How it is different than the batch RO? Closed circuit RO. FilmTech has a commercial product.
FilmTech is a
RO,
membrane,
commercial
perhaps.
batch RO commercial product is available. It was originated from Israel and it was taken over by FilmTech. And right now it is available as a product across the world. How it is different than this?
Can I answer about it?
Sure, Philip. Yeah.
Yep. So the one that thank you for the question. The one that's being referred to is called the semi-batch RO system, and ours is the batch RO system. So we've done some experiments to compare the two.
It's a batch closed circuit RO.
Sorry, closed circuit or yeah, another name for the closed circuit RO is yeah, another name for the closed circuit RO is called the semi-batch RO. So this is a name that's used in the scientific literature. I mean, both names are used, so this name is correct too. But we've compared these two things, and the energy consumption of the batch RO is about 30% less. We're working on a publication for that. Yeah. So
but theoretically, how it is possible? How theoretically it is possible? There's a thermodynamic limit. How do you stretch the thermodynamic limit? Actually,
well, we're not stretching. We're still away from the thermodynamic limit, so we're not breaking. All of these systems are away from the thermodynamic limit. So we're just getting closer to the thermodynamic limit, not breaking the thermodynamic limit in any case.
Thank you.
Thank you. Thanks for the question.
We will catch up on this during tea time.
Thank you.
Thank you very much.
I was just wondering, there were three objectives. One was desalination of water to make it potable, and second was the industrial and the domestic wastewater treatment. That aspect has not been covered in this. Yeah, I was just
shortage of time, but we are doing for dairy wastewater, nanofiltration and electrolysis, and we are ongoing for textile industry also. We targeted 2 categories which are prompt in Gujarat, dairy and textile. So we are creating solutions for them also. So maybe in tomorrow's thing, I'll come up with those industrial application solutions. Thank you very much, sir.
Thanks, Felix. So we move to the next one, Pavitra Ganga, so Paul Kempling and Schumann.
Okay, we can start. Yeah, thanks very much, and grateful to be here. Thanks for Indian government and the European Commission for funding our projects. So I'm here with Anshuman from TERI, and myself I'm from Vito, and I'll give you an overview of the project achievements within our project. Pavitra Ganga. So the objective of our project is to, can we have the next slide, please? Oh, sorry. Yeah, control, yeah. Is to unlock the environmental and economic possibilities of wastewater treatment, water reuse, and resource recovery. So we're looking at an integrated approach to deal with this, to achieve this objective. So we have wastewater treatment technologies being demonstrated in the project, which will improve treatment performance and also recover some of the resources from the waste material. On the other hand, we have smart water management approaches where we're using modeling to look at the regional water balances across the 2 case areas. And we're also using sensors to monitor some of the parameters effectively and to couple these with grab sampling. And thirdly, and very importantly, we're looking at the water governance around the wastewater treatment and reuse, because the socioeconomic aspects of this approach is very, very important. We want to look at the barriers and opportunities which are there. So, of course, under these 3 pillars, we are also active in terms of capacity building. We want to reach out to the water practitioners to bring our innovations to them. We're also looking at the business side of it and how we will go forward, looking at bringing these approaches and technologies to the market, and of course, dissemination. So just in brief, so it's a research and innovation project. It's funded, of course, by the Indian government and European Commission. We're working with 14 project partners, including academia, research centers, industry, and SMEs. So we have a very broad perspective on wastewater treatment. And of course, we've been there since beginning of 2019, and we will end our project at the end of this month. The consortium, as I say, has got some key players both on the European side and the Indian side. Is very important, and we feel this will be demonstrated tomorrow when we're looking at the commercialization and uptake of technologies that we've involved industry players and SMEs right at the start to make sure that we're getting close to market. So the structure of the project is a classic Horizon 2020 project where we integrate the work packages together to make sure that the technology developments both on the treatment and monitoring are close together, and that we form an integrated approach in terms of gaining more information and better decision making.
So not only the technologies which we felt are the very critical part of providing solution, but one of the very important component that we felt about this particular project is also the stakeholder engagement in the water governance. And for that reason, we actually looked into integrating all the verticals of the key, let's say stakeholders, mapping them and engaging with them right from the central to the state level agencies to the city level, water level bodies, and as well as the farming community on ground. So it was a very good mix of, blend of all these stakeholders right from the top to the bottom to not only engage and understand from them the perspective of the challenges that they have in the context of wastewater recycling reuse, but also to integrate them in the process of, defining and designing the kinds of solutions that we wanted to come forward with. And for that reason, we actually looked into a lot of co-creation workshops, structured decision-making to develop, shared views of problems and solutions. We use tools like MCDA, and as well as in the entire process, we came across several kind of, training and dissemination activities, including launch of a policy brief, which I'll talk about it later. This also included wastewater safety planning, which we felt is a very important component to be looked into as well as far as project is concerned. So the other, as you can see, this process actually involved a series of stakeholder, engagement workshops, both at the sites of New Delhi and Kanpur. Basically, we looked into the kind of barriers that and the factors for, good governance, as well as the entire stakeholder analysis and the cooperation workshop focused on problem structuring, for example, the wastewater management activities or the alternatives, as well as the portfolio of outcomes that could be derived in the process. We came out with several, project, briefs, fact sheets, and also the portfolio of decision-making models that has been, in a way attenuated with the project outputs. You can see a series of, workshops and possibly, you can see some of them, but it's there in the report as well as part of the engagement plan. As we move ahead, we'll share what more details about this stakeholder engagement.
One very important concept is also to make sure that the wastewater, which is used by farmers and is very important aspect is that the received wastewater is safe to use. And what we've done during the project, we've adapted the water safety plan approach of the WHO and adapted it to the wastewater safety planning in those areas. And an important aspect, again, what Anshuman said is that we've engaged with the farmers. We've used citizen-based science approaches to really flag up some of the issues around water quality in the villages which have been receiving the wastewater. An important approach, as I think a number of projects have indicated, is that contaminants of emerging concern are really an issue. It's not just in India, but it's also in Europe. And so we've done an environmental scan during the project to look at what kinds of contaminants are there. And we of course did first of all a non-targeted screening, and we had over 140 different CECs present, including pharmaceutical residues. And on the basis of that, we did a targeted analysis, and we can see we have definitely pharmaceuticals of concern. You're getting up to micrograms per liter coming up into the drinking water, including diclofenac, which is there, which is a typical contaminant which is affecting the vultures in India. Additionally, on top of that, PFAS is an issue in Europe. We know that's a growing problem, but we've also found PFAS in the sampling that we've done during the environmental scan in the 2 case areas. To go to the demonstration cases, because of course we wanted to make sure that our work was done in the real world. So we have 2 cases, the Barapilla drain, which is an open drain running through New Delhi. And we have the STP Jajmal, which is located in Kanpur around a cluster of tanneries, which has issues around illegal discharges from industrial waste. So we've, in these cases, we've brought different piloting trains. Because we want to have secondary treatment from the STP effluent. So we have two technologies there which are dealing at that scale. And also, as I say, we realize that microorganics are present, so we need to have polishing technologies as well downstream from the secondary treatment. So these are the different technologies which have which are piloted in the two case areas. Just going back to, yeah, the other important aspect in Kanpur is, of course, is that there is a major wastewater treatment, wastewater reuse irrigation scheme. Switch on the front lights. A bit darker. Yeah, so we're active at the STP site, but we're also looking at the downstream effects of irrigation, of people using the wastewater for irrigation and the impacts on the communities. These are the technologies. I will not go into detail with all of them, but as I say, it's a combination of secondary treatment and polishing technologies, which we've been working at both lab and pilot scale. But I will present some of what we see are the best upcoming technologies, of which we'll also present tomorrow in terms of commercialization. So the first one is the SFD MBR, which is a kind of pseudo MBR. We're looking at an approach which replicates a conventional MBR, and it's basically a filtration through a cake layer, which is established by the MBR, which has a lower energy consumption and a pressure gradient and a very low turbidity. And this is coming up with good quality filtrate in terms of COD and turbidity. And we can see on the left a kind of influent and effluent at this site. So this is working really well, and this is something that we will present again tomorrow in terms of commercialization. Constructed wetlands is not a new technology, but the approach is to combine different layers within the vertical pilot wetlands, so that to remove the micropollutants of concern. So the zeolites take out the heavy metals, and the activated carbon can take out the CECs of concern. And we've been doing these tests not just in India but also in Europe, and we see that the constructed wetlands plus is able to achieve what we expect in terms of removing heavy metals and also contaminants of concern. The Antikos approach has been a real challenge within the project. I think it's still a valid approach because basically we want to concentrate the sewage and combine that with other organic streams to produce through an anaerobic system biogas. But during the project, we saw some changes in the organic content of the effluent, and of course that's kind of checkmated our approach in the terms that we wanted. This was a change in the original effluent quality that would be received, and we also had issues on biodegradation in the approach. So we probably could look at different approaches where we bring in other organic streams, because one of the aspects was that there was concern about mixing fecal and non-fecal waste together, and maybe you have difficulties there. So I think it's still relevant for India because, of course, you're producing green energy through the anaerobic digestion, reducing greenhouse gas emissions. It's a modular approach, so it could easily be adapted or introduced to a new decentralized system where you have other streams which you can use. But one positive, very positive outcome is that the permeate from the IPC filtration was definitely of very good quality for wastewater reuse. Another, as I said, one of the pillars of the project is the smart water management. So we use the WEEP modeling tool to look at scenarios of bringing in these technologies. What kind of gap is there in the infrastructure for the two case areas? We also want to combine sort of off-the-shelf sensors with grab sampling so that we can use the sensor information from EC, pH, and TO, which are pretty robust sensors, combine that with grab sampling to take grab samples at the most optimum moment. And as I said, citizen-based monitoring was also a very important part of the project because it enabled us to engage with the stakeholders. And finally, out of this work, we have a dashboard which you can go to the Pavitra Ganga website and you'll see the dashboard where we bring together all the information onto one site. It's publicly available and you can use that to see what is happening in the field. This is a screenshot of that dashboard where you have live data and you also have data from previous months to see how the live data compares with the historical data. Capacity building during the project was very important. We had workshops related to smart water management and water governance. And we also had a successful technology workshop in September last year. And we brought all these aspects of the project together in our final conference last week. One aspect on top of the capacity building is that we want to make sure that our information is available to everyone. So we've made an open course network based on the materials used in the workshop, which is available to all. Dissemination, as I say, is very important. We had a final conference, as I said, last week. We're also very active in the Iowa conference in Chennai last year. We're developing publications which will be available, obviously, for people to use. We've used social media. We've tried to use different methods to engage with stakeholders. And I'll leave you now to Anshuman to look at the policy aspects of the project.
Thanks, Paul. So as I said, one of the important components of the project was to look into the engagement of the stakeholder and the kinds of, regulatory policy perspectives that we have in the context of wastewater recycle, reuse and resources recovery as well. So what we looked into was some of the very key challenges that we felt, it's very important to look into. And this came up with a lot of discussions that we have with the stakeholders at almost every level. And I thought it must be, kind of highlighted and very clearly stated out. One of the clear problem in, wastewater, and this is again an analysis of why wastewater recycle reuse has not taken forward in the magnitude that it should have been. And one of the factors we figured out was that we do not have really target-based regulations and possibly as well national reuse standards, which is sort of fit for purpose. We talked about emerging pollutants and emerging contaminants, but we are yet not monitoring them on a at a regulatory platform and forget about standards. So we felt this is one very important step which is needed to promote wastewater recycling reuse and of course monitor them with effective enforcement strategies. Then we do have many technologies, including the innovation that we talked about, but it's very important to have that policy and guiding framework for the kind of technology that is needed for the kind of reuse. So that's something fit for purpose kind of treatment, which is very, very important. Something that has been done to some extent in Europe. Possibly we can do it in India as well.
But more importantly, it's very important to know that, whether it is, used for irrigation or any other recreational purposes, even to the tune of, using it indirectly for drinking water. Not that we are recommending in the project, but this is something which is very, very important perspective to develop in order to align the possibility of the reuse at different location and for different purposes. And then, of course, what we figured out, and possibly many of you would already know, we are just reiterating the fact, and this again, because it has come out very clearly with a lot of policy, makers and stakeholder engagements that we carried out, that we are still lacking into, let's say the entire economics of, water and wastewater, wherein we are having not sufficient funding mechanisms as far as, promoting wastewater recycle reuse is concerned. And this is important basically to do because we need to have sufficient cost recovery and O&M recovery in the long-term operation, the cost of the O&M as well. And one of the clear challenges because of, this is because of the kind of typical water sector challenge that we have, which is about the rational pricing of water. Now, we need to have appropriate pricing of treated wastewater to the, which includes almost everything, including the additional O&M cost for intended reuse water quality, and with full cost recovery, perspective. And also the fact that we need to have treated wastewater pricing lower than the existing, supplies. Otherwise, it's not going to be taken up at a critical mass, value. And for all that to happen, when we talk about, cost benefit analysis in the water and wastewater sector, it really, doesn't become that encouraging because we do not have rational pricing of water itself. And therefore, that's something that is the chain that we need to kind of take up together in order to promote the water and wastewater recycling and reuse recovery in India. And IBT, increased block tariff, is one of them. I don't want to go in detail of that, but that's a very essential tool that is required. Then, of course, incentive and disincentive mechanism, we need to promote that through these tools like rebate on GST or, exemption in custom duty and many other tools which is possible. But these needs to find a wider scale and promotion and should be known to public as an available tool for, uptake of such kind of approach. Now, frankly speaking, being part of several, government committees and working very closely with the Ministry of Water Resources, I know that a lot of efforts are going on. But I think mainstreaming them, upscaling them, making them reach to the state is the key where we want to be as far as, spreading the wastewater recycle reuse is concerned. And if you talk about the state government's, policy on wastewater recycle reuse, we have just around 4 or 5 states as of now who are having this reuse policy. We need to, have almost every state, coming up with this, with all the incentive and disincentive mechanism which we talked about. So this is something which is very important. One of the things that we really figured out, and again, this came out from our stakeholder consultations very clearly, almost, ranking topmost in terms of their critical issues, is about the last mile connectivity. Yes, we have technologies already, or probably this coming from projects like ours, but how does it reach to the point of use? I am creating a technology at X location while the reuse is demanded at Y location. That last mile connectivity perspective has to be, looked into. And I think for that matter, there's a larger, let's say, implementation framework that needs to be brought out very clearly. This is something that we felt needs to be brought out very clearly from the, project. And then, of course, last but not the least, I think this is a very common, recommendation for any project. But again, nonetheless, it's very, very important. Again, strengthening an institutional capacity and monitoring capacity of the different entities and the stakeholders in the entire chain. And I think it's worth mentioning that community mobilization, awareness, and capacity building, and bringing them in forth of discussion and implementation of policy and the programs is as equally important as possibly any other intervention in our project and possibly many other projects. This is also very necessary for the sustainability of the interventions, and also in a way to have the need, and demand created for those kind of, options that we are coming ahead with. So this is very, very important tool, and I thought we must emphasize on this as well. So there we are, I think, yeah. Questions and...
So, is there any question in the audience?
You talked about water safety plan as well as sanitation safety plan. Now, were there any risk with respect to heavy metals which may be coming into the sewage? directly in the food chain, whether you were studying that. That is an important, because you advocated for more recycling. We also talking about more recycling, but we have to look into the consumer health problem also, apart from occupational health as that.
Thanks for bringing this up. Time has been short, so we can't go into too much detail. But yes, this was one of the very critical component, as I said, in our project as well. This was in one of the pillars. We did study the background. There was including the involvement of the local citizens into the monitoring process. So they as well know about the status of the kind of, let's say heavy metals and the microbes, which are there in water. The idea was to, at one hand, generate their knowledge and, capacity on, understanding the problem and the seriousness of it. But also, on the other end, when we are creating that recommendation, the chain, the connectivity is there for implementation. So absolutely correct. And this has been part of the project. In fact, we have a wastewater safety planning in which at different levels, we have come out with what should be done in terms of, safety planning. So at one end, we have come out with sort of safety plans for operation of the STPs, for example. What should they do in handling the treatment system, entirely? And on the other hand, those who are intending the reuse of this treated wastewater, what they need to keep in mind.
Yes, it's a bit to continue on the same question. We have discussions. So we have a regulation in Europe for water reuse that is coming up. It's very new still, so we don't know what has I remember in the past that the recommendation that I saw here, I saw them in Europe a few years ago. So now we have a regulation. We don't know yet what will be the consequences, and we hope that this will indeed bring forward this. We also have a work that is ongoing on the risk analysis related to the irrigation. And I think it's more a comment, but I think this project with the Indian and with different conditions, with various examples, would be very important to feed into this discussion in the GRC. And I would encourage also, so this is the Joint Research Center in Europe that is responsible for drafting this. And I would encourage also Indians, participants of the project and for other projects that are looking at water reuse to also participate to these discussions. So they are organizing workshops, they are showcasing cases where there are risk management plans that have been decided or set up. And I think this would be very valuable and a mutual value to bring the Indian cases in this discussion, even if it's the European showcase, because this is the regulation in Europe. But this would bring also additional, because I mean the concerns are the same: heavy metals, transfer of heavy metals to crops, the contaminant of emerging concerns. So all these are the same issues, and we still don't this is management. We don't have solution yet. It's practices and rotation of crops. We are talking about rotation of crops for irrigation, for salinity. That's the same also with water reuse probably. So it's just an encouragement to continue this, perhaps not with funding, but or I cannot yet promise funding.
I can maybe add to that, because at the moment we've got a parallel project funded by the Flanders government, which is looking at the case area downstream of the treatment plant in Kanpur, where we're looking at the uptake of chromium in plants and also in the milk. So it's really part of an added bonus to the project that we have additional funding to look at that and look at the real specifics about the risks.
In fact, I just quickly would respond. I mean, in India as well, we are trying to see that we are in this journey together, and we are trying to share our experiences and the solutions as well simultaneously to all the closer, agencies like National Mission for Clean Ganga, National Water Mission, Ministry of Housing and Urban Affairs. So all of these agencies are closely linked with the wastewater handling. We're trying to share our experiences and the possibilities. And I think it's a journey, as you said, possibly we'll take it together.
Yeah, one here. Nice presentation, a nice overview. But I was wondering why you left this nice policy window, which Professor Gangrikar also mentioned in the morning. that once, technically speaking, once you tune your anaerobic digestion systems, you can precipitate all the heavy metals. So your heavy metal problem is more or less taken care of. And then the water would meet irrigation standards for surface discharge. And that would be a nice way you don't seem to have taken into account. And for a good example, about 2/3 of Bangalore's sewage is now being recycled. And I didn't see why that doesn't become a model for the other thing. Are there some differences that you have which is opposing that kind of a thought process?
Yeah. Yeah, in relation to that, right at the beginning of the project, we did a sort of desktop review of different wastewater treatment cases in Europe and in India. So we are aware of other wastewater treatment or wastewater reuse schemes within India, and I think this was a very useful exercise to really try and summarize some of the barriers and opportunities, because I think we know there's a great opportunity, but there are also some issues which you have to deal with, and wastewater safety planning was one of them. So I think that came out of the sort of review of different cases around the world, and it gave us a lot of insights into what not to do and what to do in the future.
And just to add, I mean, in terms of the potential of the technology, it's not that we are saying that it's sort of not going to go forward. In fact, there are corporates within India who have taken this up in already on a commercial basis. It's just that the different conditions, as Paul mentioned, have different kinds of implication on taking it forward. And that's we wanted to share honestly as we presented.
That's nice. Thank you, Paul and Anshuman. So
someone is from the fountain.
Thank you, Paul. Thank you, Anshuman, and thanks a lot for providing the pragmatic recommendations at the end of the presentation. So there is just a small update from GIZ side. Like under the India-EU Water Partnership, which is a project delegated by GIZ on behalf of the European Union, there was one component called safe reuse of treated water. Under that component, a national framework for safe reuse of treated wastewater was developed together with Ministry of Jal Shakti and National Mission for Clean Ganga. The framework has been officially adopted by the Government of India, which was launched by the Honorable Minister of Jal Shakti in January 2023, wherein targets have been fixed that either the state governments which have the reuse policy, they should align their existing policies to the framework, or they should develop, or the states which don't have the reuse policy, they should develop their policy in a phased manner, as well as the framework also provide a kind of guidance on the institutional arrangement, the role and responsibilities, funding mechanism, and the viable business models for various end users in India. Still, I agree, like what you have mentioned, that the standards are a big thing and India has a huge way to go. But certain things have already been taken care by the Ministry of Jal Shakti. Thank you.
Much appreciate your comment, and I'm aware about that. And I think that's what I mentioned. It's a step forward, and I think India is initiating actions on that, and we are moving on that. Not that we have not taken initiatives, but I think it was important to mention that, to promote such kind of approach and innovative technologies, and them to take a sort of stage where the critical mass impact can be achieved. I think all of this have to come together. So thanks for mentioning it.
Shall I? Yeah. In view of some commonalities in our objectives in Pani water and Pavitra Ganga, you have also monitored CECs and you have about 140 CECs. Going ahead was one technology I saw where you are using ozone for treatment, right? So what kind of ozone generation you require for your plant, and what is your optimum like dose that you require for ozone? Because only ozone we found has a very short half-life. We were discussing that ahead also, before also. And that requires a specific reactor conditions for it to be mixed with your wastewater properly. So can you give us some light on that?
Yeah, I'm not the technology provider for that, but it's AquaQ, which is active as an SME. They have a system where they use ozonation in line with a fingerprinting technology to see changes in the quality of water, and then use ozonation as sort of a small use of ozonation. So they're trying to get away from using ozonation too much because it's costly, and then you have troublesome by effects from ozonation. But I'm not sure exactly how he generates the particular ozonation, but I can put you in touch with them.
Is there someone from online?
Yeah, thank you, Chairman. Yeah, nice presentation, Sir Anshuman, and also Professor Campling. Probably question is more to Professor Anshuman about fit for purpose of reuse of water in India. All of us are, as you rightly said, members of several committees. We have Bureau of Indian Standards, which all of us need to follow. Then we have CPCB norms, which we need to do. We have NGT. It has its own version of it, which none of us can challenge that. Then still we want the energy recovery. Then we want nutrients to be there in the water. Where is the catch? I mean, it's not your question, it's a question to all of us here. How do we address this issue, Anshuman, in fact?
I am very happy that you raised this, Professor Mohan, and I think you're right. We are trying to put forth all of these as a challenge together. And I think, one of the things that you might have noted in our presentation as well in the policy brief, we have clearly mentioned that while, as you know, water is a state subject in our country, and we have national guidelines and we have state guidelines. I think what is important to know that we need to have a sort of guiding framework at least, which clearly identifies, okay, for this kind of, purpose, these are the kind of range of technologies or the processes. These are the kind of, fit for purpose, range of reuse standards and therefore guidelines, which you can choose for a particular kind of application that you want to have. As of now, we have not been at the stage or the level where we need to be. And I think in that sense, I would sort of still say, I mean, Professor Mohan, I very much know that it's not yet there, but I think we need to, kind of put forth to our policymakers that this needs to be a kind of, recommend on kind of action that needs to come forth for us to be, able to, at least from the perspective of wastewater recycle reuse and many other, interventions needs to be taken care of. I mean, I also mentioned briefly about the pricing parts, which Professor Mohan, you would recognize. We always fall flat as far as the cost benefit is concerned when wastewater recycle reuse is to be, kind of scaled up. All of these are typical and critical policy interventions which are required. Some of them are, having political connotations. We cannot discuss them as of now. But I believe, to start with, we need to have that step, forward, where we have to have those guiding frameworks. We need to have those, guidelines, which actually gives a clarity of what needs to be done, how it needs to be done, what are the options, and as well as I mentioned earlier as well, that financial support and marketing mechanism altogether. Unless this all comes together, the success, it may not happen in one go, but we need to take that step to move ahead towards that.
Thank you, Professor Anshuman. I think it's a very nice thing. But only thing is, in all these things, we need to talk through data, where especially our European friends, if they have used it at several times, they have gone through this process. Some of them good, some of them the other things. When we have the data, and even here also we should have to generate some data out of these projects and go with the data to the government. I think then only we'll be able to depend. Thank you.
I totally agree with you. Just a quick comment on that, sir. When discussing with Ministry of Water Resources as well as being member of BIS as well, have been telling them as well, we need to come out with our own research-based standards. Borrowing is one part, maybe for time being that can be done, but we need to look into those response relationship-based standards, developed for our country. And it might take some time, but we need to have that process, in place.
Thank you.
Thank you. Thank you. Thank you very much. Sir. Thanks a lot. We invite the last one, Spring.
Good afternoon to all. I, Sanjukta Patra, stand here with Curie to present the progress of the SPRING project. Good afternoon to all. I, Sanjukta, and Professor Raj Kale is not there, but with me will be Yuri to present the progress of the SPRING project. So in the SPRING project, we will be moving from the water stress to water security and water health. When we talk about water stress, it is contributed by various factors, which are mostly anthropogenic in nature. And here we will try to find out what are the contributors. In the first objective of the project, SPRING went down to two study sites, the river Ganga basin and the Godavari Delta. Here, in the first objective, we went down to these study areas and we tried to find out what are the contributors and try to figure them out as point and non-point sources who are contributing to this, followed by real-time monitoring systems, which was carried out both by the European as well as the Indian partners, which could help us not just identify these pollutants, but categorize them and then also suggest how they can be taken up for different kinds of remediation purposes, which are not just eco-friendly in nature, but also sustainable. After this, one of the unique things about the SPRING projects is the advanced bio-oxidation process. So it's something beyond the oxidation process where we are trying to carry out oxidation, which is absolutely biological in nature. We'll be talking about this more. These are the SPRING partners which are spread across Europe and the different parts of India. The first study area, which is which is West Godavari Delta. Here we have the SRKRC Engineering College, who has very meticulously come up with all the polluted hotspots in this particular region. And there, from that region, we have the Elixir Biotech, which is the SME partner, and the municipal corporation, which has been absolutely too much cooperative with us with regards to many of the implementations which was required to be done. The other study area was the river Ganga basin, where the leading partner was IIT BHU, and they also carried out the entire thematic presentations of this particular region, followed by IIT Guwahati and IIT Kharagpur, where we worked on the advanced bio-oxidation process and the scale-up of this bio-oxidation process, which can be taken up for the remediation purposes. We also had with us D.Y. Patil and Pallavi Trust, an NGO, which tried to come up with different difficulties which we face when water is transported through the pipelines and it gets clogged. And here they have come up with a robotic system which can help us identify, remove, and also deliver required payloads for remediations at these sites. So with this, we move forward straight away to the objectives which we have done. So in the first objective, in the Western Godavari Delta region, carried out by the SRKRC and the SRKRC, they have come up identifying So these are the various thematic maps based on which we have come across identifying 77 locations which are point and non-point in nature. Now, why point and non-point sources are important when we want to talk about not just finding out the contributors, but also how we can remediate. Because point and non-point sources, definitely we can point sources are easy to handle, or even plan out strategies when we talk for remediation of water. That is because one of the best examples of point sources are industries, which are discharging continuously into the various water bodies. So handling point sources is easier because it can be, we can suggest them guidelines, and also it's easier to monitor the pollutants which they are delivering at the discharge points. Wherever, when we come to the non-point sources, they are mostly difficult to regulate, and hence they require different kinds of strategies when we have to remediate them. So 77 locations were identified, which were based on all the drains and canals of the West Godavari Delta region, which were they were very much reflective of the social side of the anthropogenic activities which have been going across in all the regions. So they can be divided into the industries which were contributing, the aquaculture, agriculture, as well as the residential areas which were there, and also, of course, the solid waste disposal units. So all these were differently contributing to the drainage system, which were ultimately polluting the entire water bodies. Now, out of these 77 sites, they identified 30 hotspot regions across the canals and the drainage systems. These hotspot regions, they were having the pollutants at a much higher level as from the normal expected guidelines as per the government bodies. Out of these, all these were identified as a hotspots. And finally, we have identified some demonstration sites of our technology, of the technology which we have developed in the project. And then this has been taken up in these sites. So these are also we would like to point out that when we talk about pollutant heterogeneity studies, the role of, in India, seasonal variations is a very important thing which is always there. So we had the data spread across the pre-monsoon and the post-monsoon seasons. Also, one more thing to point out, that water quality is also, there are different standards of water quality which are required with regards to usage. Hence, the maps were created with regards to them also. Now, similar thing was pointed out, similar pollutant heterogeneity study was parallelly carried out at the Ganga River Basin. Here, we would like to point out that the type of agriculture which exists in the Western Godavari Delta and that which exists in the Ganga River Basin, they are quite different. And also the industrial points which exist, they are different. Hence, we did observe the different in the pollutant heterogeneity map which was generated. One additional thing which IIT BHU came up with was, so these are they identified 16 water quality sampling sites they had, out of which they had 3 different hotspots which are listed here, where we will be carrying out the demonstration of our technology. Now, one additional thing which IIT BHU came up with was the water health index. So this is different from, this is an additional thing which is with regards to the inorganic and organic pollutant measurements. This is because it indicates, it is measured with regards to the biological systems which evolves when there is pollution. So they have 6 different biological entities, right from bacteria to algae to macroinvertebrates and fishes. So they are indicators when water is polluted. So biological entities are the best indicators of pollution. And this was taken into account, and they created the river health monitoring system. So this we are also implementing, not just for river health monitoring, we are also trying to use it for other water bodies which are polluted, even if they are stagnant water bodies. So this was also one of the products which was of the project. Now, coming to the second objective. So after identifying the type of pollution which exists at a particular place, the next step is how to remediate it. So there are multiple remediation systems which we have been hearing about and which exist and which have different advantages and disadvantages. In the SPRING project, we talk about something which is called the advanced bio-oxidation process. So when we add the word bio here, we want to say that it is about generating H2O2. If you simplify it, it is about generating H2O2 through a biological system, which is an enzyme here. So here, the H2O2 generated through the enzymes is broken down to hydroxy radical, which are the ultimate reactive oxygen species, which have a very high redox potential. And the best part of it is that it can address multiple pollutants, as we see here. Reactive oxygen species can target organic pollutants, can target antibiotics, and also many other things as we see here. Now, these are some of the examples which the enzymatic advanced bio-oxidation system can take care of. So one of the examples is that it can take care of organic matter created by any kind of pollution. So that is one. Then the second thing, one of the other industries which we have also worked with is the textile industry, where the pollutants are mostly the dominant pollutants are starch. So here, in addition to that, we have another enzyme which can work on the starch generating glucose, and this glucose can be acted upon by glucose oxidase, which can give you H2O2 in addition. So we hear two different enzymes here. And then the third one is a paper industry waste, which can be targeted using an additional enzyme of cellulase along with the xanthine oxidase, which we talked about in the beginning. We also try to come up with the pollutant heterogeneity study of the leather industry wastewater and the organic matter present over there, along with the proteins and other things with the advanced bio-oxidation process. This is the dairy industry wastewater, where the lactose is one of the major pollutants, along with, so here it can be acted upon, again, glucose oxidase to give H2O2, and xanthine oxidase also contributes to giving H2O2, and this can be acted upon. Another emerging pollutant which we try to monitor was antibiotics. We monitored two different antibiotics in the point as well as the non-point sources. And in the point sources, mostly it was aquaculture as well as pisciculture, and also piggeries we targeted as point sources. And in the non-point sources, different different points of river Brahmaputra, as well as some other water bodies, and also some pharmaceutical industry wastewater. So, and the solution for this we have with two other enzymes, which is manganese peroxidase and lactase, which again act on the principles of reactive oxygen species generation. So these were the different point and non-point sources which we use for the advanced bio-oxidation process. Now, the next thing is, whenever we are talking about the process, what about the scale up? So when we talk about the advanced bio-oxidation process, we scaled up with one enzyme, which is xanthine oxidase. And here, the work was carried out, the scale up of this was carried out by IIT Kharagpur. And the final, and we did it to a scale up of around 4 liters. And the final unit of enzymes which we got was around 39,417 milliunits per ml of protein. And here we'd like to see, when we talk about the cost things, the cost thing which I am talking about is at the initial expression thing, not after the scale up. It is around one third of the market cost which we have for the purified enzyme. So these are the deliverables from this particular objective. Now coming to the next objective, which is about development of monitoring systems. When we talk about these point and non-point sources, which are spread across these two river beds. So we have come up with the project has come up with a prototype, which you see here, which we have named as SRAM, which is the, RSAM, the real-time sensing and monitoring of samples. So this particular prototype is can be remotely controlled, and it is free floating in any kind of wastewater or water bodies, stagnant as well as moving water bodies. And it has 6 different sensors embedded in it, which can collect data on a real-time basis, and the data can be can be monitored and stored from anywhere. Anywhere you want to access from, and you can just scan it across with the QR code, and you can access the data. So it can be used by the consumer It can be used by any industry. It can be used by any regulatory, like any government bodies. And the cost, when we talk about the cost of this particular, this is a product which has already been awarded by some of the some of the competitions which we had appeared for. And here we see the cost of the material. It is at around 12,000 for a particular, for one of the prototypes which we develop. And similar materials, when we see which exist, similar things which which exist in market is much higher, as you see here. Now coming to the next technologies, the three more technologies which are coming up was carried out by the European partners, and Georgi will be taking up that. Thank you.
Okay, thank you so much. Okay, so as Anita said, practically one aim of the project was to develop and